that have actually been the developers of the software, those pieces of software, so we can hear from them. And they'll do kind of walkthroughs of their tool. There will be an Athena walkthrough too. That'll happen in the afternoon. So the afternoon there'll be like more hands-on. And that'll be the most important time to have your computer running if you're pressed for battery power. Save it for the afternoon. And then we'll finish up with a kind of in-class exercise using Athena. So we'll do the walkthrough, get a chance to see how it works. It's a very simple program. And then you'll build up a model and we'll talk about the results and try and actually achieve like a 10% reduction in global warming potential. I skipped over these here. We'll also be talking, Natalie will be talking about the M1A and M1B requirements for B3 guidelines. She'll also talk about the Buy Clean program and the overlap between those, the B3 buildings and the state buildings, where you might be kind of juggling both. And then I will complete the morning session with just kind of running through some examples how to achieve compliance with M1A and M1B. How many people have been to this workshop before? Just two. Okay.
Long time ago.
Yeah. This is maybe the third time or fourth time we've run the workshop. So repeat customers, that's a good thing. I'm going to skip this slide. How many people here, though, are interested in the AIA credits?
Sure.
Fair number. Okay.
It's on a sheet for people to
I think
put
Roshni.
Roshni.
Yeah, Roshni. So what is LCA? At its kind of most simple level, it's tracking flows of materials, inputs and outputs, or sometimes we call those outputs pollutants. And they're kind of tracked. They're tracked at the idea is to track those inputs and outputs at each phase of a product's life cycle. So you see here kind of a linear progression. We can also think about turning that into a circle and reusing products and recycling, but here it's shown as kind of a linear progression from extraction and processing of the raw materials through the manufacture and distribution, and then the construction of the building or the use of the product. And then finally the disposal of that. So at the end of the life, the building's demolished and what happens to all those materials. And again, at each one of those steps, there's going to be inputs and outputs. And the life cycle analysis is supposed to be tracking that. So some of those inputs could be, for example, energy or water, raw materials. Some of the outputs could be various kinds of pollutants. Some could be going into the water, some could be going into the air, some could be going into a landfill. Here's a circularized look, but more specifically, life cycle analysis is going to really drill down and find out what are those specific resources that are going into the product that's being, or the building that's being fabricated. So maybe it's tracking water, iron, sand, oil, limestone, all these like particular resources. And each one of those are associated with a certain amount of pollution, a certain type of pollution, a certain amount of energy consumption. Like that's the embodied energy going into that product. On the emissions outside, we're also being pretty specific about what's being tracked. So oftentimes it comes down to actually specific chemicals that are being released. CO2 is a big one, of course, we're all familiar with, but there's a lot of other pollutants as well that are tracked. And once you have those lists of inputs and outputs, the next step, that's called an inventory. The next step is to try and translate that to what are the actual impacts on the environment, because that's what we're interested in at the end of the day. And those can take the form of of many different types. So you can have, climate change impacts. We can have air pollution impacts. We can have acid rain, which isn't talked about too much anymore, but that was big in the 80s and 70s. You can have water pollution impacts like eutrophication. The value of LCA, sorry about this boring slide here. But the value, hey Billy, we may be out of table space.
Okay.
Oh, okay.
That's a little too.
Billy, do you want to introduce yourself real quick?
No. Okay. Sorry, I'm late. I'm Billy Weber. I am a lecturer here at the School of Architecture. I teach in the MSSD track. And starting tomorrow, I will be the associate head of the Department of Architecture, Landscape Architecture, and Interior Design. Congratulations.
So we have some, one more. Hi. There's a chair right there. Got the last table spot. So there's some value to LCA that we don't get with other type of certification programs or product statements. Primarily, it's the value of real data. So as I was talking about, all these different, what we call the life cycle inventory, the tracking of specific materials and resources and emissions. And the idea behind LCA is that it uses kind of this process of transparent disclosure. So we're not hiding behind a statement like, I'm a local product or I'm a green product. You actually have to put your numbers on the table and show, and then you can compare that. That's done through the EPD process, which we'll get into in just a moment. How many people have heard of EPDs? Yeah. And we get to address the embodied impacts, which sometimes are ignored. I think that's changing. A lot of us are tracking energy consumption in our buildings, but tracking the embodied energy or the embodied impacts. That is a growing field. And we can find, using this process, we can find hotspots. What that means is like in the enclosure or in the building structure, there might be particular components that are more impactful than others. And we want to zero in on those and see what we can do to have kind of the biggest bang for the buck if we're interested in reducing the environmental impact. So again, as I mentioned, a lot of products have these kind of statements made 55% recycled content or it's a local product. And that is just kind of without more data, that's a lot of greenwashing is what that is. We don't really know if a local product has lower environmental impacts than any other product. It may, because it's not being transported, but oftentimes the transportation is not particularly large component of the overall environmental impact. So we use EPDs, some real data to figure that out. This is kind of the results from an EPD. It's kind of a scorecard. Again, that's the basis for this transparent disclosure. Natalie is going to talk a bit more about EPDs, but there's several different types. Are you going to talk about type 1, type 2, type 3? No? Okay. I don't get into EPDs too much, but there are different kind of levels of EPDs. You all actually probably get in more EPDs than I do. But you can have generic or industry level EPDs, which are broad scope kind of for an average across the whole industry. This is what 3000 PSI concrete is. Or you can have product specific EPDs. Okay. You can have product specific EPDs or plant specific EPDs if you're talking about concrete or steel, where they measure at this particular fabrication site. This is what our emissions are per pound of steel or whatever it is. And you can have third party versus self-verified EPDs. So third party obviously better because we're getting an outside group to come in and measure those or at least verify them. Self-reported EPDs, I don't know, do many people use self-reported EPDs? I don't think they're as common as they maybe used to be, but just be aware of these different types. Okay, let's see. So we get to address embodied impacts. We're building these net zero buildings, but oftentimes we don't know how much embodied energy went into that. And if I have seen projects that have advertised net zero energy and they're very efficient, but they end up using tons of spray foam or blowing agents with HFCs, and their global warming potential outweighs all the emissions benefits for decades. So it is important, especially as we're ratcheting down the consumption side, the emission side during the use of the building. On the flip side, the embodied energy is becoming a larger and larger fraction of the total. So we do need to start paying attention to that. That's just a graph showing kind of how the operating emissions increase over time. But if we're interested in shorter time frames, like I think we should be for climate change, we have a very short window to make a difference. On that, we need to look at some of the short-term impacts as well, and that's where embodied energy comes in. And then, as I said, hotspots. So this is it's a look across several different environmental indicators or impact categories. And then what the software has done for this is just generic software, but what it's done in this case is try to lay out what the impact is in each of these categories by building components. So we can drill down and say, okay, this is the wall is here. It looks like it's having an outsized impact on our greenhouse gas, our embodied carbon or embodied energy. So let's go look at that. How could we reduce that? A lot of these tools you can then focus in on just the wall component, the wall assembly, and see, what the distribution of materials, how the distribution of materials there is impacting or creating that embodied energy or embodied carbon. And in this particular case, maybe they have maybe this is a curtain wall or something. So there's a lot of glass, and glass has a really high GWP, and maybe it's like rigid foam insulation. So behind the spandrel panels. So we can zero in on those particular aspects and start looking for alternatives or products that have, we can start pulling their EPDs and find products that have lower impacts. So at the end of the day, however, LCA is not the end all and be all of, it's not going to be our environmental savior. It's just kind of one tool in our tool belt. We still need other programs, other processes to kind of provide this complete picture. Particularly, I have learned that on issues like biodiversity or site-specific impacts and human health, LCA is not great. So oftentimes, for example, I think we'll probably see this as we use the software today. Wood looks awesome. Super low environmental impacts for using wood. But we all know that in reality, wood has a huge, variability in its environmental impact. It could come from, the rainforest in Brazil, in which case it's really not good. Or it could be, recycled wood chips from, some plant in northern Minnesota where the impact is relatively smaller. So that's where these programs like FSC and SFI come in, and they help us make those better choices where LCA has kind of fallen flat. Building certification programs, that would be another example in the whole building world where, we're not tracking probably indoor environmental quality very well using LCA. So we use those building certification programs to do that. And finally, LCA is really still an estimating science. I started learning about this when Billy was my instructor, and it hasn't really gotten a lot better in terms of the variability of impacts and just kind of the uncertainty factor in impacts of these materials. This is a screenshot from EC3. How many people know EC3? Heard of EC3? Yeah. So this is showing the whole range, a very wide range of impact for a specific product category. And then they say, okay, now you pulled out this specific material, but look at the uncertainty is still large just for that specific product. It's taking up a significant fraction of the total range. There's a lot of uncertainty built in. And here's another look at concrete. So you can see where some of the tools are showing the performance. This is embodied carbon. And there's a big variety. The National Ready Mix Concrete Association is down here at 20% of what Tally is estimating for 3,000 PSI concrete. That's almost half of an order of magnitude difference in something so basic as concrete. So there's a lot of variability built in. And it's this graph also explains why we don't want to start comparing results from one tool to another. So within, if we picked Tally here for 3,000 PSI concrete, and then we were comparing it to Athena at 4,000 PSI, we would get the wrong picture. It would say, oh, 4,000 PSI is better. So we have to stay within one tool set. And if you notice, if you do stay in one tool set, they say the same thing. As the PSI goes down, the embodied carbon grows less. So if you stay within one tool set, the absolute impacts might not be correct, but we're relatively confident that the relative impacts are at least help us make good design decisions. So why do the impacts vary so much? This is an extremely complicated field. There's a lot of things to track. If you can just imagine what it's like to go back to a factory and try and track all the inputs and outputs, and do that through every phase of the life cycle, there's a lot of unknowns. And a lot of people scribbling numbers down based on how many miles they drove to get, it's like it gets a little crazy. So there are protocols designed to help people do this consistently. So the ISO 14040 series is defining some of those mandatory elements of how to do an LCA, how to get reasonably consistent numbers. And the EPA has created now Tracy 2.2, I think, is the most current version that tells us how to take those inventory results, the specific chemicals and resources, and translate those consistently into environmental impacts. So that's where Tracy 2.2 comes in. So this ISO series is kind of how do we come up with the LCI or the inventory, and Tracy 2.2 is like how do we translate that into the environmental impacts. And by the way, if you have anything to add, just jump in. So I think I've kind of explained this a little bit already. But we have, sometimes many hundreds of chemicals that have been tracked as emissions during the production or the use in the construction of a building or specific products or materials. And we have this challenge of how do we compare that across different material types that may have wildly different chemicals that are being emitted. So one product might generate, like concrete might generate a lot of carbon dioxide, but another product might generate a lot of sulfur hexafluoride. And how do we compare those two in terms of their global warming impact? We have to use what are called indicator molecules for each of these pollutants. And then we have to translate those. We have to say how many molecules of CO2 is one sulfur hexafluoride worth. So at the end of the day, we got to work down to a consistent set of molecules or indicators that we can compare across products or buildings. So that's where Tracy 2.2 comes in. Here are some of the major indicator molecules and the environmental impacts they're associated with. Global warming, of course, is the one a lot of us pay attention to, but there's all these other eutrophication, ozone depletion, smog potential. Primary energy, the embodied energy is another one that we often talk about in this field. And that one might be in terms of kilowatt hours or BTUs or whatever, but they all come back, kind of use these chemicals as the unit of unit basis for comparison.
And E stands for equivalent.
Equivalent, yeah. Unfortunately, when we're using these molecules and we say these are the environmental impacts, it's very difficult. It's kind of like the field of public health. Like, can you say that this cigarette resulted in your cancer? No, you cannot. It's a kind of a field of probability. And that's exactly the same story here with these chemical indicators. We can't tell if that chemical actually made it up and destroyed an ozone layer molecule. All of those impacts are just based on probability assessments. So that's one of the main drawbacks. It falls especially short on health, as I mentioned. Very hard to track that back to actual sickness or cancer cases, things like that. Moving one step further, I should just pause there for a moment. I've been speaking a mile a minute. Any questions with all that so far? We're moving a little bit. Yeah, go ahead. Yes, they are. And hopefully you have a PDF. Yeah. Yeah, go ahead.
The PR is the EPD, but is that a little separate then from what you're going on?
Do you want to handle that?
Yeah, the PCR is for a specific product category, and then it defines the rules of what goes into the EPD, what goes into a whole LCA for that product. Say ready mix concrete has a specific PCR that's different than asphalt. And it says how you account for A1 to A3 emissions in the EPD for that specific material. And it's agreed upon by a PCR committee for that specific material product category and updated every few years. But follows ISO standards. Does that answer your question?
Yeah, good question.
Back on the slide, you're talking about how you can't compare program to program. And so what you had showed was like different PSIs of concrete. The trend was the same. Does that also translate to like material comparisons? Like one of these programs isn't going to say cut your concrete and a different one's going to say cut your steel. Like, are they similar across the board, even if their actual like quantities are different?
Yeah. Yep, they are. I think you'll find pretty consistently that steel has lower impact than concrete across the different tools, for example. I think that's the question you're asking. Yeah. Yeah. Would you say? Would you agree? Yeah. Yeah.
The EPD is kind of like a nutrition label for a product, right?
Yeah.
Do you know if those are developed by federal standard or is it industry standard? Like what goes into those?
The EPDs. Well, again, I think, correct me if
International standards, ISO, defines the rules for setting PCRs, which are product category rules, which also define rules for what goes into the EPD. And so those are international standards that
industry or by
industry helps to do the PCRs that are material specific. And I believe industry can help and join the committee, the ISO committee for international development of standards as well. But I would say nationally, I've seen a lot of activity on especially the asphalt and concrete PCRs in the US. A lot of folks that I know that are tangential to our Minnesota Buy Clean Task Force or other task force are also on these PCR committees, informing what should and shouldn't go into EPDs, how the information is displayed, details like that.
So, I mean, a lot of times you need the industry expertise.
Yeah.
So that's why they're invited and at the table, because they say they know their factory and their processes better than. Yeah.
So if I understand where your question is coming from correctly, at the beginning of EPDs, and I'm sure everybody here is aware, it lists this like ISO 14040, like they'll say what it's compliant to, but your question is like peeking behind the curtain. What does that really mean, right?
Yes,
Okay,
this is
and
the context of the court ruling yesterday, which is letting Monsanto off the hook because it was a government standard versus an industry standard. So I'm like wondering if in the long term, these standards, I'm sure some of these stuff in our products cause cancer. Imagine, right? Will that be on the industry, or who will take liability from that?
oh, that's even a separate question.
Yeah.
Right?
Yeah.
Exactly, but that's what's driving.
Yeah.
And the short answer is PCR committees, but the longer answer is like everybody and nobody. Yeah.
Yeah.
Or unless you have an idea. as to
No, that's
the
good.
accountability there.
You know, PCRs are freely available or are those behind a paywall?
I don't know. Do you know?
I think I've been able to download from like NSF or there's a page I can send a link out if you're interested. I think I've been able to download all the PCRs that I've been looking for the materials on the task force. I haven't had to hit a paywall yet, but maybe for some products there are paywalls. But at least for asphalts, ready mix concrete, CMU, I've been able to get those updated ones.
Dictations for the EPDs, like a customer or well and weed that says like, oh, that's great, but I want it to have this, I want it to have this included. Do you see that forming upward into these and then coming back down?
Give me an example.
Like a customer like, I don't know, Google or somebody who has a very high sustainability goal says, thanks for this EPD on this product, but I want you to include this aspect as well. Or I really am interested in this aspect on this product, but it's not dictated by PCR or EPD. Do you see that coming out and then working its way back up, coming apart with PCR?
I don't know. I mean, I think elements like that would probably be better incorporated into like owner's project requirements if they have specific things they're searching for or need.
Like the impetus of declare or the red list.
Yeah,
Word.
product declarations.
Yeah.
I just didn't know if that was like pretty well settled now, or like, because obviously in the early days, it was probably lots of requests and trying to capture them all. And maybe now we're like, cool, we got most of them covered.
Yeah. I don't think
I've seen on like as like a one-off, if a client wants more than the EPD, they can sometimes ask the EPD provider for the backup LCA that informed that EPD to get the background information. But I don't see that as becoming required on every single project. I see that as like if a client wants it and the software provider is willing to send that information to them. I do know, I think Illinois Department of Transportation, I believe they're now wanting to not only ask for EPDs for some of their procurement requirements, but they're also wanting to get the backup LCA data. I don't know where they're at in actually being able to get that, getting folks to submit that on their state projects. But those are a couple examples. Okay. But I would say join the PCR committees if anyone wants to try to be in that process and inform what goes into EPDs. I know for the concrete EPD, they're trying to get A1, A2, and A3 separated out so that those are distinct, and then also the sum of A1 to A3, whereas in asphalt, it's already been in their PCR for years. So I think in the next concrete update, hopefully we'll see that the GWP split out for those life cycle stages.
But I think your question touches on what comment that you made, that LCAs aren't the end all be all, right? They've been now like coupled with health product declarations to get a fuller impact assessment, right?
Yeah.
And EPDs, you had them listed below, kind of track a handful of environmental impacts.
Yeah.
Right?
Yeah. It's not a complete picture. So moving into the whole building LCA world now a little bit, I think probably many of you have seen this chart before, but it's a very important chart. It lists the different product or different stages of the life cycle for a building. So a lot of times when we're talking about EPDs, we are stuck in the A1 through A3, the product stage. That's all that the manufacturer deals with. There's also these A4 and A5 stages, which is what happens to get those materials or products to the building site and the construction sequence. So those, we know there's inputs and outputs, emissions there as well. So that's this construction process stage. Then we have this whole B stage, which is the use stage, upkeep and maintenance, cleaning, replacement, all of those things that are happening. But sometimes that's quite important. If we choose a product that doesn't have a long life cycle, that ends up getting replaced multiple times. So you're adding every time it's getting replaced. Let's say your lifespan of your LCA is 60 years. You might have to replace your vinyl siding 3 times. So it's vinyl siding times 3. So that's where, this use stage takes that into account. And then we have the end of life stage, which is the deconstruction and the disposal of all the materials. The reason we don't just rely on EPDs is because EPDs are focused just on A1 through A3. So it's an incomplete picture. The whole idea of the whole building LCA is to get the whole life cycle. And in fact, then beyond there's some things like recycling or recovery or reuse, which are kind of summed up in something they call phase D. For LEED and B3, when we're talking about LCA, we don't typically look at that phase D. Those phase D impacts are normally crossed out. We're looking at phase A1 through C4, minus operational energy and operational water use. So that's like, the natural gas the building is burning in its furnace, or the electricity that the air conditioners are using. Those are also extracted. So as I mentioned, I kind of was alluding to this. Lifespan is a pretty important factor in LCA. And unfortunately, a lot of our commercial buildings end up going this way in 30 years when the strip mall dies and all the, like that concrete, glass is demolished. Those were long-term materials. And a lot of times our residential structures, which are built out of wood, are maintained and lived in for hundreds of years. So we have kind of this inverse, the wrong material for the wrong process or purpose. But again, that's why the life cycle, estimating a lifespan is important. It turns out that we have to just kind of pick. We don't know which direction our buildings are going to go. Sometimes they may be demolished in a short time frame. Sometimes they're not. We just need to pick a standard and kind of stick with it. And in the LCA world, that has been primarily 60 years. So it's a long enough time frame where really short-term materials do get several replacements. But we also can see some benefits from using longer-term materials like a brick, like brick cladding or something like that. We know it has a long lifespan. Its impact is high up front, but it's averaged out over those 60 years. So it can start looking better when you're comparing it just to like vinyl cladding or something like that. So picking that lifespan of the building is kind of taken out of your hands. The consistent standard that we use is 60.
For federal work, 60 has been kind of the norm forever. Now we're seeing people don't do much federal work at all anymore. 60 years has been used for commercial, but like you said, there's often a mismatch there.
Yeah.
It shows that we're trying to achieve a building that could last 60, plus years, but that doesn't actually.
Right.
This topic, so I understand needing a standard when we're doing comparative analysis and like reporting type things, but do any of the tools offer a design team if it's not about like, hey, I need to get this credit for lead, if it's about, hey, I want to make a better design decision, and you know your client type, you know their tendencies, you know the likelihood of when they're going to actually demolish it. Is there any ability for these tools to let someone pick like, hey, we actually need to make the best decision for a 20-year building because we know that's what this building is going to end
Great
up.
question. Yeah. And yes, the short answer is yes, you cannot, that's usually one of the first inputs. At least it is for Athena. You know, the first window that pops up is like, this is my building lifespan. So yeah, you can decide that on your own. If you're working outside the B3 program or lead. Yeah.
Yeah, and in Tally, I think you can actually go even more in more detail, and for specific materials or parts of assemblies, set different life expectancies to those materials, and then you can set the whole building life expectancy for the scope of the whole LCA as well.
Is there a good guide or resource to tell what lifespans of different materials or assemblies are?
That's a good question. I don't know.
There might be something in the American Council and LCA. I'll have to look it up. We can send you a link.
Does anybody here know the answer to that question?
I tried to do that, but I've only cobbled together stuff. There wasn't like a one stop shop. If you're Googling. Yeah, and I'm not 100% confident.
Sure.
Right. What I did is I just tried, right?
Yeah, that's where we're at too.
Yeah.
It's hoping.
All right. Well, do people need to stand up and take a really short break? We have just a couple minutes before our guest presenters start. Should we just plow through? Plow through. Okay. So I'm going to turn it over to Natalie.
Join and talk. Can we put that window above? So we share the speaker window. We'll give a brief overview of some whole building LCA tools, and then we'll hear from some folks from One Click LCA, C-Scale, and Tally. So here are some tools. This is not an exhaustive list by any means, but these tools are from the lens of the end user and the usage for the LCA. So on the top, we have CIMA-Pro, Gabby, OpenLCA. These are tools and software that are more for LCA specialists, consultants that are hired to produce product or material LCAs or full LCAs for buildings. And again, this is more of a specialist program, not kind of for your everyday designer and user. And then we have EcoConcept and EC3. These are geared more for consumers and designers, but looking more at the product selection level, product substitution level. And it's a little bit more of a streamlined process to use these LCA tools. But at least for EC3, for instance, it's mostly focused on A1 to A3. Sometimes you can input separate values for A4, A5, but it doesn't actually calculate that for you in the program. So it's kind of not the full picture for a whole building LCA. And then on the bottom, the bolded first 4 tools for LCA, Tally, One Click LCA, Athena, and C-Scale. Well, all of the tools in the bottom row are geared more towards architects and designers, and are looking more at the whole building scale rather than on the product level. And the first 4 tools that are bolded cover the complete life cycle for a whole building LCA, whereas Beam Estimator, Revit Carbon Insights, and a few others that our B3 team has kind of heard of or heard people ask about, their scope is limited, typically only covering A1 to A3, that product life cycle stage and not carrying all the way through the end of the building life cycle. But these are just some tools. And with these tools, our end goal is to estimate the embodied carbon impacts from the materials, processes, construction, all the way to the end of life, the cradle to grave. Some LCA practitioners do cradle to cradle and do include Module D. For B3, we do not include Module D emissions, just to the end of the building life cycle. Let's see. Oh, in terms of LCA scope, typically LCA includes structure, enclosure, foundations, floors, sometimes interior walls and finishes. LCA typically does not include fixtures, furnishings, mechanical, electrical equipment, plumbing, HVAC, lighting. However, with MEP 2040's program, I think they're the industry mechanical engineers program for net zero embodied carbon by 2040. I think there's a little bit more analysis and energy being put into quantifying carbon impacts for MEP systems and weaving that into whole building LCA results. But that is currently not included in the scope for B3 whole building LCA.
Yeah.
Yes.
Do you have any sense of like what portion is missing then from the LCA picture by leaving out mechanical equipment?
I've heard, I can't speak to exact numbers, but I've heard anywhere from 5 to 20%. It just depends on the building, the mechanical system size, what the design parameters are. But Nathan Cagle, I don't know if you heard him speak, I think a couple US Green Building Council like transformation forums ago, he's like, it's like 40% or something. But I don't know the exact number. So, but do you have any ideas on? Yeah,
no, I did hear him. I was presenting at that one.
Yeah.
But
Yeah. Yeah. So it's, some people have said it is a kind of more of a significant portion that we might have thought in the past, and that it's important to think about including it in whole building LCA scope in the future. We're just not quite there yet with our B3 requirements and scope, but it's definitely something that could be reported on optionally outside of the GWP reporting and the B3 tracking tool, which we'll get to later.
And it seems like with just like refrigerants, right? They're dealt with separately because they realize that it's like a little less. So again, not a part of LCA, but tracked separately.
And then, whole building LCA may also include operational impacts. However, for our B3 tracking, we do not include operational impacts in our calculations. Some of you might have heard earlier you talk about it, the more often you talk about it, the higher likelihood it's going to appear in your project, or it's going to become important in your project. And earlier on in design, when you're thinking about material selection, thinking about material salvage or reuse, kind of in the pre-design phase, there's a lot of opportunity to have a bigger impact in terms of reducing your embodied carbon on your project. But then as the project kind of moves along, you get through design and construction, kind of those decisions get locked in. And so there's less potential. There's still potential with like material substitution level savings in embodied carbon, but the most potential is in the beginning. And currently, there aren't a ton of tools that help with estimating embodied carbon in pre-design. However, there is one, which we'll talk a little bit about later, that has the potential to carry from pre-design all the way to a more detailed analysis and documenting compliance for certain green building programs all the way through construction and use phase. So here's, again, not an exhaustive list by any means of some of the whole building LCA tools, the ones boxed in red we're going to touch on today. I won't touch on Athena. I'll just zoom through the slide because Rolf is going to go deep into that later. But we will hear from Spencer from One Click LCA, and then we'll hear from Jack Rusk, co-founder of C-Scale. And spoiler alert, if you guys haven't heard, in April of this year, C-Scale acquired Tally 2.0, and they're helping to launch the new version of Tally. So we'll get to see a preview of that today. So again, we'll talk more about Athena Impact Estimator later because that'll be the focus of the afternoon session. And without further ado, I would like to hand it over to Spencer Jarrett from One Click LCA. And he'll give a brief introduction to the program and then walk through a live demo.
Thanks, Natalie. Good morning, everyone. Spencer Jarrett here with One Click LCA. Just give me one moment here to share my screen and we can get started.
Too loud.
All right. Let's see. Can you all see my screen now?
No. Oh, yeah, how do we do that?
Just close.
Or here, what if we go? What's this? Go to the Zoom.
Is the slide deck coming through on your end?
Not yet.
Not yet.
Oh, okay.
It is showing on the screen, but we just got to get it transferred over to the.
Should we just plug my computer in? For this. Will that work? Work. Come on, technology. You can do it. Yay. Okay, sorry.
Oh, yeah.
Someone could just give me a thumbs up or something when it's finalized. Okay, great. All right. Sorry about that. I'm not sure if it was my end or yours. But this will be a pretty quick overview of how you could use One-Click LCA in your workflow for the three requirements or for LEED or any other whole building LCA. Really focused on what is an LCA or LCA 101, since that's already been covered this morning, but really about how you can take the tool and use it from really early stages, early design decisions, all the way through detailed quantities that you might have from modeling things in a BIM file through construction, and then through as-built LCA, if that's something that you need to do. So One-Click LCA is a suite of tools, all focused on measuring embodied carbon in construction. So to start, just want to cover, sorry, the slide is not changing. There we go. Just want to cover the different stages of design and construction, really design here, and the different avenues that One-Click LCA offers to start assessing embodied carbon from day one. So we have an early design tool called Carbon Designer 3D, which I'll get more in depth on after this slide. That's really focused on taking basic parameters about a building, the building type, its size, its overall geometry, and taking some assumptions to go ahead and model a specific building with different geometries and substitute in and out different materials for the structure, for the enclosure, for all parts of the building if you want to. But really, the structure enclosure is what we're looking at in those early stages. And as you develop your designs in other software tools like Revit, Grasshopper, etc., One-Click LCA has integrations with all of those. So as you refine your design, you can pull data from those sources to refine your LCA model to see, does it match up with our early stage assessments? Are the hotspots still where we thought they were? Are any of the quantities way out of line? You can start to get a little bit more detailed as you pull information from BIM. And then within One-Click LCA itself, and One-Click LCA, by the way, is a web-based software. So you just log in on the web to use it. Within One-Click LCA itself, that's where you actually would do a lot of the EPD mapping. So matching the materials on your proposed design to the best EPDs that we have available. Within One-Click LCA is a consolidated database of all of the EPDs that are public that exist across the world. So you have a really robust database to find EPDs, find materials, start thinking about which materials you want to use, maybe which manufacturers of certain materials you might want to use based on their plant-specific EPDs and different things like that. But the overall goal of the tool is to find hotspots early on and try to reduce those hotspots. So just getting briefly into Carbon Designer 3D here. Carbon Designer 3D is, again, for very early stage modeling, taking the building size and type and going ahead and generating quick models based on some of those basic parameters. So what this looks like in practice in the software is you can actually draw out the floor plan or multiple floor plans for a building, and then go ahead and model that in 3D. And what One-Click LCA provides is basically a menu of industry average EPDs for each part of that building that you see on the screen that's modeled, where you can substitute in and out different material types for different models. So you can see in the third image here, we have 4 different scenarios for the same proposed building on the same site that you can model. And then to the right of that, I know it might be kind of hard to see, but those are different parts of the building broken out by their carbon footprint. So just a way to easily make some of those comparisons early on before you lean too far into one particular exterior wall assembly or particular massing idea for the overall building. That's where this tool comes in to sort of guide those ideas. So once you're a little bit further along in your project, most designers are using Revit or some other BIM tool. You can start to pull in quantities from those BIM tools to One-Click and refine your LCA model from there. Or you can stay right there inside of Revit and isolate different modeled elements in 3D view, and right next to it, you can search the One-Click EPD database and match a specific material EPD to a specific part of that model. But this is really where you can iterate over the Carbon Designer 3D model. And by the way, all these models can be viewed at once in the software. So you can see, in real time, have you reduced the hotspots that you found, or are they going up? And in my experience, BIM files don't have all of the materials that you need to do a basic structural or envelope LCA. And, in the case of LEED version 5 now, which I know LEED was referenced quite a few times earlier, is now requiring hardscapes as part of the LCA model. Most BIM files that I've handled at least didn't have the hardscapes in there. So with one-click LCA, you can take multiple data sources for the materials and dump those into the same LCA model, just in case everything is not in the same place. So you have your material quantities in the software now, and the next step would be actually matching those material quantities and material types to EPDs. So within one-click, there's a couple of ways that you can do this. The screenshot on the left there is a list of materials. So you can go in and physically see the full list of materials. You can change the quantities. You can change all of those life cycle stages after A3, which is typically where many EPDs cut off. So you can go ahead and factor in transportation to the site, the vehicles, the materials were shipped on, all of the operational impacts, repairs, refurbishments over the course of each material's life. You can edit all of that in the software. In terms of actually finding EPDs, there's a chatbot within the tool. So you can go ahead and ask the chatbot, show me all of the concrete EPDs in Minnesota, and it would go ahead and give you that list. Or you can search as you normally would, and filter the EPDs down by program operator, by date that it's published, by manufacturer name, and so on. So a lot of different ways to find EPDs. But the quickest and easiest to use tool within one-click LCA is called the Materials Compass. So that's what you're seeing on the far right. Basically, that tool allows you to open up a map and see different plants, different manufacturers that have published EPDs geographically, and just use that as a reference to start building your own internal firm repository of materials or assemblies that you want to model later in future LCA models. So in terms of actually documenting the results and helping you along through the LCA, out from one-click LCA, you can run a number of different reports. So within the tool, there are certain compliance modules already made that you can use for schemes that are a little bit more widely adopted, like LEED version 5. In California, there is they have their own regulation, Cal Green, requiring embodied carbon assessment. We have specific tools made for that, but for B3, you can use our generic North American tool and then just customize the results page to show the outputs that you need for B3. Now, when you get to the results page, there are some tools in there to help you if you are newer to doing whole building LCAs, or you just want to double check some things. We have a plausibility checker within the tool. So basically, this is checking to see if the carbon values of each of your materials fall within typical ranges, and also looking at the quantities, which in turn typically drives the carbon value, making sure that they are within typical ranges as well for a building the size of the one that you've modeled. In any LCA tool, sometimes it's really easy to completely skew the results. Maybe if you forget to add a 0 to a quantity, or you add an extra 0, can really throw things off. So there's just some QA tools built in there to help you along. So just sort of wrapping up here, this is just typically looking at who would own the data and what stages that different data would be used for the purpose of an LCA model. So for most LCA models, the architect and structural engineer have most of the information you need. If you are further along in the process, and you didn't have the opportunity to start that early, maybe your construction manager or GC has material takeoffs that you can use. Maybe they have submittals already that have been approved, that you can go ahead and start finding EPDs, hopefully for those materials. But all of this can be done, within the platform. And just to wrap up here, some some takeaways. I know it's already been mentioned, but start early. Within the one-click platform, we have Carbon Designer 3D to help you with that, to free draw different geometries of buildings that you are considering. You can also put in other parameters such as zoning restrictions into that tool as well. So it would auto-generate the geometries for you rather than you having to draw them. And then as the design matures, continue to update your LCA model with that, just to make sure you're on the right track. It's really easy to have a really pretty conceptual carbon model that you're using to guide your design. But then if you don't continue to model all the materials, all the quantities as that changes, then it might not match up in the end or when that project goes into construction. And then I would say any software tool for LCA is a tool. There still needs to be some oversight when it comes to choosing the materials, checking those quantities, looking at the data sources, the data quality. All of that is super important as you're going through the LCA process. So the tool is there exactly as the tool. It's not the end all be all of what the overall impact of that building should be. So definitely still a lot of human influence that needs to go into modeling whole building LCA. So that was a lot of information, pretty fast, I know. I'm definitely open to taking some questions now if there are any. If any of you want to talk further after this, feel free to reach out to me. There's a lot more that we could talk about just when it comes to some of these specific tools within the platform. But this is really all I could fit in 15 minutes. So thank you.
On mute,
Yeah. Can you hear us?
Can you hear us, Spencer?
Yes.
Okay, great.
So a lot of us, I'm assuming, use Revit. I'm wondering if you can speak just a little bit more on the interface or what's needed to sync or link or use the Revit model within the LCA. I'm sorry, one-click LCA.
So Spencer, did you hear that question? Should I repeat?
Yes. Yeah, I can answer that.
Okay.
So the Revit integration is widely used, obviously, because most architects are using Revit. There's a couple of different ways that you can go about using it. One way is you can stay right there in Revit on your with the model open and 3D view, and you can open up the one-click LCA plugin right next to your model. And from there, you can start searching the database, matching EPDs to your materials there, and get quick results based on what you've done there, right there in the model. Quick results graphically with different colors about where the hotspots are. The more that you map your materials to EPDs, the software will remember what you map to, what you like to map to, what your colleagues like to map to. So then the more LCAs that you do, that's a little bit more automated. But the other way to use the Revit plugin is to send your entire model into the web application, one-click LCA, and refine it from there. Now, to make that completely seamless, where it really is one click, there are some parameters around how the modeled elements need to be classified and named, really getting down to their classification, the family and family types for each one. We have a whole guide on kind of the nitty-gritty of what needs to be done there. But long story short, if you name everything correctly, you can click the button and send your entire model to one click. It'll go ahead and find the EPDs that match those names, and you don't really need to do a whole lot of work in the application at that point. So just for brevity, I'll leave it there, but there's a few different ways that you can go about it.
Nitty-gritty that you're talking about also includes, well, we use Revit for composite walls, right? And so it has all these different layers, but it wouldn't make sense necessarily to model them all individually in Revit. So the nitty gritty that you're talking about, I would assume addresses that, right? So it addresses these wall assemblies that actually have embedded in them multiple components. So we wouldn't have to model each of those separately.
Yes, that's correct. Yeah,
Yeah,
there's a
okay.
few ways to go about that. Like you can, and it also depends, of course, on the level of detail in your model. So those considerations were taken in with the integration. If you do have every layer modeled, that's great. That's that I've yet to see that. If not, there's some different ways where you can go about taking just the mass of the wall and then delineating out what each layer would be. Or you can do things like take all of the like materials that go into a composite wall for the whole project and consolidate, let's just say for like a wood framed wall, consolidate all the 2x wood into one material line in your LCA. And then another line would be all of the insulation and so on. So yes, there's some consideration given to that, definitely.
What about claddings that require like furring or, Z-girts or subgirts, or does one-click LCA address that somehow? So you're not just, say, looking at the cladding itself, but you're also looking at the subframe?
Yes, definitely. Yeah, there's actually several subgirt EPDs out there, if I recall. There's a few companies that actually make greener subgirts than just the typical, but yes, that would be handled in the same manner. One thing that's a common way to use the tool when it comes to what you're talking about, different assemblies, is rather than modeling a whole building within the software, you could go through and layer by layer build out, say, 1 square foot of a typical wall for your project. And then you can model 1 square foot of another option that you're considering with each layer built up there. And you can get a really quick estimate that way of what is the carbon impact of a square foot of this wall versus this wall. And then you can save those.
Yeah, that would definitely be the route to go.
There's
That's
a question in the back.
Yeah, I got a question about that, what's it called, the Carbon Designer 3D, that seems like an awesome tool. Is there any discussion, or are you, like, it'd be nice to be able to compare the changes in carbon associated with the embodied carbon versus the changes in carbon associated with the performance? Is that something you guys offer or are looking into? Like I guess there's quite a few like shoebox models out there that will be able to give you a rough estimation of the operational carbon associated with that basic geometry. Is that something you guys are looking into as well?
Yes, absolutely. Yeah. Currently, that tool, it doesn't have those parameters built into the model, but stay tuned. Later this year, we're going to have an update on that tool where it will incorporate energy use and also the microclimate around the building as well, if that is something you wanted to consider when it came to shading and sun and all of that.
Right.
I had one question, Spencer, about the reference building. Did I hear you say something about automatically generating the reference building to calculate your reduction percentage from?
Yes. So in that case, that would take you having to build the reference building once, and then you can pull that out. If it matches the parameters of your specific project, you can pull that out and use the data that went into that reference building to make a more specific one for your project relatively quickly. So within Carbon Designer, you can create customized templates for different building typologies or projects that you might want to quickly just have a reference for.
Okay, thanks.
I had a question about EPD mapping. Say you wanted to upload your own EPD that you got from like a ready mix producer. What's the process to do that? Can you upload it directly into your own one-click database, or does that get sent to one-click and then it has to be added on your end? Or what does that look like?
You could do either one. So if you have one that you want us to add to the database, you can send that to us and we would do that after it's been vetted and everything. Or you can just, it would be a lot faster for you to just go into your account and add what we call a private resource, where you would just make your own data point essentially at that point based on that EPD. But only you would have the visibility to see that and use it in the LCA.
Got it. Any other questions? All right. Well, thank you so much, Spencer.
Yeah, of course.
And
Thank you
we'll
for having
share-
me.
Yeah, if you could send the slides to us, then we can share it out to the group after our workshop today. And I'll send them your contact info as well in case they have any other questions about one-click. And
Okay,
is
yeah.
there I guess like a free trial for folks if they want to try one-click out?
We do
available?
have some options for that. We also have some free trainings that you can do as well, and through that you can get access to the software and play around with it yourself. So yes, I can share that.
Great. And then up next, let me see. We have Jack Rusk, co-founder of C-Scale, and he's going to talk about C-Scale and Tally 2.0. Welcome, Jack.
Awesome. Yeah. Can you see me? Is this working?
Yes. Yes.
All right, amazing. Thank you, Spencer, for that. Thank you, Rolf and Natalie, for hosting this. I'm going to dig into two separate platforms. I'll show a few slides, but really I'll try to do this as much as possible with live demos. If I share my screen and I'm clicking on a tool, will people be able to see that level of detail? I'm just trying to figure out like what the room looks like that y'all are in. Like, is this legible to people here?
No.
Maybe people with better eyes.
This is kind of what the room looks like. I don't know if you can see through the camera, but Rolf's computer.
It's a little small.
But
It's
all
a little small, but I think we can see your cursor okay.
That's better.
Do some zooming. It helps. Okay, well, I'll zoom in a bit. We'll try it. I do think it'll be more engaging, if nothing else, to be looking at a tool instead of a slide. I'm going to show two tools. One is a web platform called Cscale. That's really a collaborative platform for firms to manage this data together across their portfolio. There's free personal accounts, there's free organization accounts. Tons of folks use it without giving us a dollar. I hope you do too, because our goal is really to use this to get a carbon assessment on every project, everywhere, by every firm. The goal of Cscale is to enable teams to get started as early as possible in pre-design and early schematic when the biggest decisions are made, but the least data is available, and create a continuous process from pre-design all the way through into Revit-based assessments, construction documents, and as-built and procurement guidance. So I'm going to sort of default firm now. All of these projects are projects, we'll say, generated from within the firm. Really, the idea here is that this is a shared working environment where designers can do their work, directors, principals, and project managers can review the work, and the team can collaborate together to get to carbon assessments on 100% of the projects. So I'll run through very quickly what it means to start a new project. The idea of really streamlining this new project creation process is that teams with only 15 minutes to spare can do a preliminary carbon assessment. And hey, if you have 15 hours, you can move into Tally in Revit and really do the full assessment. But getting started should be quick, fast, and easy, and allow you to iteratively drill down to impacts to understand what's at stake. So, to get started, you really only need the information that you might have during, when you get the RFP. So I'll enter a project name. I'll call this Minnesota K-12. It's new construction completed in 2027. And I'll just put the address generally as somewhere in Minneapolis, climate zone 6A. We'll call it a K-12 school, working in imperial units with 6 floors, and we'll call it, gosh, I don't know, 55,000 square feet above ground. It'll have a U-shaped footprint, reinforced concrete structure. Cladding type is thin brick rain screen, punched windows, and we'll say the roof is typically built-up roofing. You can set all kinds of scope here. I'll start with a very simple one. A 6-year analysis period, like Rolf talked about earlier, is the default. We'll focus on structure, enclosure, and interiors. And I won't generate any pre-generated scenarios, so we can do it all ourselves. And just that amount of information is what you need to get it started with an assessment. This assessment's always a whole life carbon assessment. So whole life carbon means the embodied emissions up front, also the operating emissions over time, and refrigerants, right? We're really looking at the full life cycle impacts here. So the business as usual case is your base case. You can go in there and edit it in various ways. Maybe I know a little bit more about this baseline. I know, for instance, that my energy use, say the EUI I might be targeting for the base case is 60. Combustion is probably common in these buildings, but it's probably actually only closer to 20% of use, right, of the total energy use in the building. And we start to see interesting dynamics here, right? We see this little curve that happens in these early years. We can look at this annually. You see the big sort of spike of embodied emissions the first year. You see the grid decarbonizing in Minnesota here, and you see the persistent sort of signal here, right, of the emissions from fossil fuel use. So really the idea here is, I think Rolf showed this graphic with these time slices from various years. When you look at the annual emissions, you see the clear spike in year one. And when you look at the emissions cumulatively over time, you see why it's important to reduce embodied emissions up front, because it's a big number. And over time, you see why by year 60, hey, there's a lot of emissions, right, from the energy use in the building. So we might create a new scenario. We'll call this, we'll just model something like a net zero project. And for this net zero project, I'll keep using this energy use tab. I'll get down to something like an EUI of 20, say. I'll electrify the building. And I'll maybe say I'll install a PV array that deals with 100% of the load. It'll size it for you. That's about 20,000 square feet. And now we're at net zero. And now you can see very obviously that all the remaining emissions, we can look at the reductions, feel good about ourselves. You get to something like a classic net zero project and you still have a lot of emissions left from the materials. You can look at how those are distributed across structure, enclosure, and interiors. And now this is where you can really start digging in once you've dealt with some of the hot spots around energy use into the embodied emissions. So we'll start with enclosure. We made our typical enclosure choices early on. You can get into detailed design, which lets you dig much further in. Somebody mentioned things like GERT within these. Anytime that a user in CCL makes a simple choice like thin brick rain screen, there's a lot of takeoffs behind it that says, you just selected the thin brick rain screen, but actually there's whatever this is, like 8 or 9 materials, right, that go into that assembly. And when I change this to something like EIFS, all of those takeoffs are recalculated to ensure that really you're always getting a holistic view of all the impacts in the project. These are all still marked as predictions. You can start to edit it as you get more specific material or information about, right, your project. Maybe you say there's exactly 30,000 square feet of this. Maybe you want to start to edit some of these individual quantities. Maybe there's some shading devices you want to model by adding some aluminum, say, some anodized aluminum finish material, and you think that's going to be something like, whatever it is, do some takeoffs, and there's all sorts of units you can do this in. It's probably a crazy number I just put in there. Apologies. Maybe 4 tons. You can start to edit the units. You can mark every single material as to whether it's new construction, existing to remain, or salvaged. Even within the assembly, actually, say I have this EIFS assembly. Say the stucco, the asphalt underlayment is new, glass mat gypsum's new, but hey, actually, this cold form steel framing is existing to remain. And the polyiso actually as well, we're just recladding over something is also existing to remain. And if you want to look for a specific EPD to support that with, you can get into here. I really like this John Manville stuff. I'll assign it to that product. And you can build out your full LCA, starting with really simple choices. Is it EIFS or is it brick? And getting all the way down to the product specific level in a pretty straightforward way. You do this for enclosure, you can do this for structure. Same, move into the detailed design. You get the quantities and can move this down to the EPD level. I won't sort of do too much here because I'm trying to squeeze 10 pounds of sugar into a 5-pound bag to get this demo done in a reasonable amount of time for y'all. But with all that, right, you can start to model some of these reductions to the various, we'll say, like aspects of the building. Same with interiors. You start by selecting typical wall types, typical flooring, typical ceiling, and can get into the detailed mode and edit, down to the stud, right? How it all comes together. And this is really what exists in the web platform. You can mark these things as targets. You can export data for the 2030 commitment for one project or for your whole portfolio. A lot of folks are using us for AI 2030 reporting sometimes hundreds of projects, sometimes tens, sometimes just 4. We'll take it all. The per hour project data or different sort of reports. And really, like as you do more and more of this work for individual projects, you can start to build up these portfolios where firms often will say get a lot of value that take the results across the firm's work and puts it all together on a common basis, reconciling a lot of the messy scope that makes comparing LCAs difficult, and use it to sort of do benchmarking and baselining across the entire portfolio of projects, right? So rather than just being a tool where you get a PDF out at the end and you submit it, really we see LCA as a way for firms to take, we'll say, more agency over the way that the material choices they make across the firm affect the design, construction, and emissions across all their buildings. So here's a portfolio of projects by this firm. You can start to see, the different hotspots for total emissions, et cetera, as we firms sort of work to rank and understand relative impacts here. Looks like this West Campus Lab is a relatively high emission building, but hey, this little renovation is relatively low. And that's all in the cloud. Y'all asked a lot of questions about Revit. I'll move into the Tally section now, and Tally really is the Revit-based version of this same assessment. So moving my screen over, now I'm in Tally within Revit. I'll see if I can zoom in here a little bit. Might be a little small, sorry about that. Oh, I did a terrible thing. Sorry about that, okay. So we're here in Revit, we're working in the Revit model. I have Tally open. Tally's an add-in for Revit, right? This is the new version, actually released today to the first 30 firms involved in the beta. And what you do in Tally is you go through the Revit model and you say like, hey, what's this 18-inch concrete, section? So I'll look at this and I'll say like, let's isolate that in the view. What are we looking at here? Okay, I remember modeling that. I'll, reset that height isolate. And I'll go and I'll map these materials to impacts and move through the model, mapping these impacts to get to the full sort of picture of the project. So I'll go to here, I'll edit the definition of this material. Concrete, it's cast in place. It's, we'll say 4 KSI. There's different takeoff methods. I'm just going to do it by volume and custom density. I know that, well, we'll say like, I would ask if we were in person, if anybody in here is modeling the rebar in their slabs or no structural engineers that are. If you do that, I know where you can go to get help. It's okay, but like Spencer mentioned, there's a lot of things that aren't present in the LCA model that are really important, or in the BIM model that are really important to be reflected in the LCA. So here you can do things like add steel reinforcing rod, different takeoff methods to sort of do the takeoffs for that. So we'll use a reference density for this sort of reinforcement, moderate reinforcement for these slabs. no reuse. And what am I missing here? Da, da, da. Da, da. Oh, I have custom density here, so I'll use default density. I'll save that. And as I define this, I like this definition. I actually use it for all these basic walls. So I will copy that definition and paste it here. And I'll paste it here. And I will actually use the same for this retaining wall and this retaining wall. And from all of these choices I make modeling this, you can also model different, somebody asked about layers of an assembly. One thing we love about Tally and we're really excited about is it has a lot of really granular smarts about the way, building science works, right? Ensuring that when you model, say, for instance, what we just did, a slab, you make sure there's rebar or welded wire reinforcement within it. When you have things like a roof, that there's cover boards. When you have things like, a rain screen, make sure that there's girt and, vapor barrier, right? Uh, so there's all this really detailed assembly takeoff logic here to make it really simple to build a good model that obeys the laws of physics, the way buildings come together. With this too, you can view the results all kinds of different ways. Here's hotspots by division. You can look at it by life cycle stage. You can look at it by Revit category, however you like it. Tables of results in any given way. And all of this works across all of the impact categories that Rolf was talking about. GWP, the carbon metric, acidification, eutrophication, etc. As a way that you can start to do this compliant LCA directly within the Revit environment. Now, the thing we're working toward this summer is how these two pieces of the puzzle fit together. And I think that's where, when we think about like workflows, where it gets really exciting for us, is we really see so much potential in C-scale for what we call sort of the pre-BIM workflows, all the big decisions that get made when you're deciding, to build or not to build, right? To reuse or to retrofit, or to build new, right? Whether it should be a mass timber or a concrete building, whether it should be 6 stories or 2. All of these things really often are decisions made before we're in BIM. And that really is what the web platform excels at. But eventually there's, you're in Revit, right? Like every project, all roads lead that direction. So linking that project defined in the cloud to the BIM environment, allowing designers to design, iterate in Revit, map the materials, generate LCA results live within Revit as they're modeling. The ability to get the results live is a major improvement that we've been working on since Tally 1.0. And linking all of that data back up to the cloud so that for every designer who's in Revit using Tally to do the modeling, there's another person who's the project architect, who is the, sometimes even the client actually, or the sustainability director of the firm, who needs to review the material choices, vet the model, ensure compliance, but who does not probably have a Revit license, right? But is either responsible or a reviewer of that work. And we see this two-way data exchange between the Revit environment and the web as being essential to making it possible to allow everybody to do, right, the work that they need to do in the right environment. So that web layer really helps with the review, with the collaboration, and with the reporting for LEED, for B3, for things like Cal Green in California, or different bike lane programs being spun up in different places across North America. All happens in the web. And the ability to track impacts across the portfolio so that firms can do things like report to 2030, so that firms can do things like benchmark their own performance to understand if their next project is better or worse than their previous ones, right? Is really where we see a lot of potential in the web platform. And as we move forward through Tally and C-Scale, the next thing we're super excited about tackling, probably not until 2027, is getting deeper into submittals and RFIs, because we see so many projects get their sustainability goals totally they start to fall apart when you move into this process with contractors, and it's really hard to review this information. So again, the goal of C-Scale is really to support this sort of analysis from the very beginning all the way through construction, and to make it cheap, fast, and easy. There's a lot of free stuff that we offer. Cscale generally is free to use. There's some things like reporting and exporting that you need a firm-wide license to do, but even that actually there's a free version of that as well. So really just the ambition here is to build the mechanisms to get a LCA done on every project everywhere. We're releasing the Tally 2.0 beta actually today to the 30 firms. I think I mentioned that earlier, and it'll be in a more general release probably by September or October. I'll stop there. I know this whole thing's running a little long, so I want to make sure there's time for questions, but thank y'all.
Thanks, Jack. Any questions? Yes.
Something that I've really struggled with is being able to select appropriately the building type, just because many of the work that I do doesn't fall neatly or nicely under a certain category. So there's that's maybe a more general comment. The second thing is I've worked on buildings that, well, large or small, that have multiple structural systems. And in the past, I've had to basically run multiple then models and combine them together to kind of yield one LCA result. You dealt with that. Third, you mentioned that Cscale is a whole building use cloud-based platform. I didn't see how you selected the utility or the energy mix. If you could really hone that in. Oftentimes mechanical deals with that kind of separately and then informs us being architects. And then I'm working on a lot of projects where we have owner provided PVs, usually on the rooftop. How is that then factored into the energy mix?
All right, I got utility and energy mix, the problems of building use type categorization, and owner provided PVs. Did I miss anything else?
For structure, if you have multiple structural
structure.
systems.
Yeah. Thank you. Cool. So multiple structures, totally understand. And I think with all of these things, maybe the framing comment is abstracting buildings into like nice little parameters is super difficult. You know, you might have a college building that's a university building as it's reported to the DX, and it's classrooms, and you might have the same one and it has a data center in it, right? Like they're both university buildings, but there is this essential problem of categorization that lives across all of this. I think my question and what we try to reconcile ourselves with is if you're doing AIA 2030 reporting, how do you characterize the project there? And typically that matches 1-to-1 with Cscale. And that's why exactly like we use the choices users make around things like use type to set good defaults and get a starting point. But at the end of the day, you know, there's all sorts of editing you can do to get our assumptions out of the way and get your specific data in there. So I'll do the structure thing, you know, we'll say I'll go back to the simple editing mode where you can sort of pull the big levers right and left to see what matters. We'll go from a reinforced concrete building and we'll add a secondary structure. Let's say it's wood frame. And with this wood frame building, I'll say that it's 60% wood frame. And we start to see here again the reductions, not just to the operational emissions, but we're starting to see actually these reductions to the structural emissions that you get from those substitutions. So we allow this sort of simple version of primary, secondary structural modeling at the early phases. We try really hard not to show people nice 3D pictures of the early phases, because typically that has too much specificity for the actual kind of data and granularity you're working at. But this is our approach to this, primary and secondary. For the energy use, our PV module is actually pretty powerful. You can do all kinds of stuff with it. If you say, hey, the owners provided 6,000 square feet of PV, you can just enter that number directly. If you want to do an even more detailed design for the PV, you can start to get into all of these other parameters, the tilt, the azimuth, the general loss percentage, to understand that at a higher degree of resolution. So that's all there. If you have, when you say utility mix, I'm going to answer that two ways. One is the use of energy within the building. This you can configure here. So say if this building's not all electric, there's some percentage of on-site combustion, and you can set that here as a percentage of EUI. Maybe the owner's going to make a clean power purchase, right, from the building. You can start to offset electricity use there. And then on the other side of it, hey, where are these carbon numbers coming from that are motivating this projection of the grid? Here, we work with what's now the National Rockies Lab or whatever, NRL, used to be NREL and will always be NREL in my heart, where we use these future scenarios from Cambium. And that's all documented in our docs here for you to review. So those are sort of the standard forward-looking projections of how the grid will perform from now into the future. That's enshrined in things like some upcoming ASHRAE standards and is our main reference for future carbon emissions from the grid.
Great, thank you.
I think there's one more question.
Yeah, less of a question, more of a comment. One of the things I love about C-Scale is you can compare scenarios really easily. And that's one of my challenges with Tally. I know you guys just acquired them, but is that something that's going to be available in Tally 2.0 or what's the thought process on that?
Oh, you're muted.
Muted, sorry. Is all these different kind of comparison graphics you can sort of look at. So here's comparison of emissions over time, comparison of life cycle emissions, different sorts of summaries, and you can just export these, use them in presentations, etc. It really is all about like design optioning and design scenarios. This is something that's on the roadmap for this month as we work from the Tally alpha release that happened today to the kind of like more fully baked beta release, is really reconciling the definition of the scenarios and design options as they exist in Revit to what exists in C-Scale. It's tricky because Revit is such a unbounded environment, right? You can have anything sometimes in a Revit model, and getting the options to have, we'll say, substantive guardrails so that we ensure comparisons are always apples to apples. That's really where the rub is going to be, to ensure that options as they're created in Revit maintain a basis of comparability, like we can just sort of like enforce in the web application. So stay tuned there. Lots of exciting stuff. And if anybody here like wants to participate in this early Tally testing, come on in. Like the more kind of feedback we're able to collect in the next 2 months, the better off it'll be. So anybody who wants to use the messy early version of it and turn these questions into specific feedback, like we'd love to have you. No cost.
Great. Thank you so much, Jack.
Maybe say thank you to both Spencer and Jack for their time today. It was really great.
Thank you.
So I'm going to go over credits M1A and M1B briefly, and then dive into Buy Clean and how that impacts the future requirements for M1B. And then Rolf is going to talk about how to achieve compliance in more detail with some examples and workflow. So credit M1A, in case you haven't looked at the B3 requirements, recently is the whole building LCA requirement, and there are 3 pathways. Let's go back. So there's the whole building level, model the whole building to do the LCA. There's path 2 is an assembly level, model just a part of the building, and then multiply it by however many modules to scale up to a whole building analysis. And then there's the path 3, the product or material level, really looking at product substitutions to achieve reductions through the credit. So path 1, the whole building LCA approach, is modeled mostly after LEED requirements in terms of LCA scope. And for this, you create a reference building And then you need to demonstrate at least 10% global warming potential reduction compared to the reference building. And the 3 approved softwares, like we mentioned before, right now are Athena, Tally, and OneClick LCA. Path to the assembly level. This can be used for projects that have a more uniform layout or like a simple structure type. And this can be done, taking your assembly, taking your whatever bay, and then multiplying that to get the full whole scale building LCA results. Easier to model than a whole building, but can only compare assemblies that are functionally equivalent. So again, with this pathway, the requirement is that you must document at least 10% reduction in global warming potential compared to the reference building, which Rolf will go into more detail about how to set that reference building up, the scope of the LCA, the life expectancy of the building, all of that. And then path 3 is that product material level, very quick and dirty, but it's limited, can only compare materials that are functionally equivalent in a material substitution manner. And then path 3, material level LCA approach. So this is using the material selection calculator that basically is a very, very high, quick and dirty. You put in different material properties for your building, and then you have to meet an impact score of 1.65 or less for a regular building, or 1.75 or less for small buildings. And again, Rolf will go into more detail of how what that actually looks like in the material selection calculator in a few minutes. Let's see. And then of recent B3 buildings, this is a breakdown of the different pathways that buildings have chosen to demonstrate that 10% reduction in GWP. So most of the buildings have gone with the whole building LCA approach. We don't have the percentage breakdown, but you can see that big blue swath. And then the gray swath, that's maybe, I don't know, over a quarter of the buildings have gone with the material selection calculator. And then a much smaller portion of buildings have gone with the assembly LCA, likely because there's probably not a lot of building types that you can really just cut and dry and say this represents the whole building for this one bay. And then credit M1B. So the current guideline requirement basically says that 5 EPDs or product specific declarations need to be submitted on the project from at least 5 different manufacturers. And if it's an industry-wide EPD, currently you get half of a product credit. So say if you wanted to submit 10 industry-wide EPDs, that would fulfill the 5 EPD requirement because it'd be counted as half. Or if you have product-specific type 3 EPDs, that will count as a whole. So currently it's just 5 different permanently installed products you must submit EPDs on. The forthcoming updated requirements, which folks, if you're on the B3 newsletter mailing list, should have received the updates, the drafts of the updates, and we're gathering feedback currently over the next few months before these will go into effect. But these forthcoming updated requirements, it will still focus on EPDs that are type 3 that conform to ISO 14025. However, there will be an expanded list of materials. So it's not a number dependent. It's not like submit 5 minimum EPDs. It's really going to depend on what materials are in your project that are eligible materials, which I'll explain next. And the way you input the EPDs right now in the tracking tool, there's basically a table and you kind of input the product name, EPD name, expiration date, and you upload a file. For the new forthcoming requirements, updated requirements, there will be an Excel tracking sheet rather than uploading into a tool within the tracking tool. It's a separate Excel sheet that hopefully folks are, it's table format, kind of line item by line item. And there's some pre-selected materials, material categories, some other tabs in the Excel sheet, which I'll show a little bit of later, explaining which materials you need to submit EPDs for. But all of this is really, the updates are really coming from the new BICLEAN requirements, which I'll talk about next, and really how we integrate the BICLEAN requirements with B3 moving forward. And so Minnesota's BICLEAN program, I have had the pleasure of working with Richard Graves at CSBR for the last 2 and something years. And most of that work has been focused on the BICLEAN program because we have a unique relationship with the Department of Administration and helping to implement the BICLEAN program and helping to facilitate the task force that is informing a lot of the recommendations that go into the program. So a little bit of history just about embodied carbon policies in general. Probably can't read all that, but especially the last 5 years, we've seen a huge uptick globally on embodied carbon policies, with some of them incorporating whole building LCA as well. You'll notice 2023 is when Minnesota came on the map for embodied carbon in the BICLEAN program specifically. I mean, B3 has been around for much longer. But in 2023, I guess here, I'll talk a little bit more about the Minnesota policy specifically, but a number of other states have different levels of implementation of BICLEAN programs, including, Washington, Oregon, New York, California, Colorado. And for Minnesota, sorry about that. Our BICLEAN policy was signed into the BICLEAN by FAIR Act in 2023. And then in October of 2023, the task force mandated by the policy was formed. And like I said before, this program is about EPDs for now and requiring EPDs be submitted for eligible projects and materials to demonstrate compliance with global warming potential standards that are set by the commissioner at the Department of Admin, but informed by task force research and the legislative reports that get submitted every year, which are all available on the Minnesota's BICLEAN website, which is linked here, including our legislative report from last year, task force meetings, presentation slides. And so the task force, as I mentioned, was formed in 2023, and it's just a huge wide array of folks from industry, different stakeholders, environmental groups. We got material suppliers, architects, engineers, designers, construction firms. So a wide array of folks. And the meetings, they're happening around for a year until 2028, end of 2028. And they're open to the public. Anyone can come and listen in and ask questions. And so, yeah, since 2023, the task force has met quite a number of times. I mentioned the legislative report. The first one was in December of last year, which went to informed the global warming potential limits that were then set on January 15th of this year for concrete, ready-mix concrete and rebar used in buildings. And that's for buildings 50,000 gross square feet or larger, or renovations of a similar scale. And then kind of important dates coming up. July 15th is the implementation date of the global warming potential limits on projects. And then I'll talk a little bit about what Built Cold is, because, okay, yeah, what are we going to do with all this data, all these EPDs coming in for projects? How will we use that to inform future global warming potential limits? Because as you'll see in 2028, that is when the commissioner will establish global warming potential limits for structural steel, asphalt paving, and concrete pavement. Right. So a little bit more about what is an eligible project. I mentioned new construction of a state building, 50,000 gross square feet or larger, or renovation of a similar size. And then eligible materials are carbon steel rebar, structural steel, concrete, and asphalt paving mixtures. And the task force every year is also looking into other materials that might be high impact, that might want to be included in some form or another in future years of the policy. And for this is the definition of state building from the policy. It's a building owned by the state of Minnesota or a Minnesota state agency. So that would include like Minnesota universities as well. Let's see. And then I guess regardless of funding, if the building is 50,000 gross square feet or larger, it has to meet BICLEAN requirements. So it doesn't have to do with the funding source, but for B3, as you all know, any project that is funded from general obligation bonds needs to meet the B3 requirements. But there is that kind of overlap if you are using the general obligation bond funding mechanism and your building is 50,000 gross square feet or larger, you need to meet these requirements. But the way we're setting up the submittals and the check process, if you meet one, you should meet both. So it'll be easy, making it easier for teams to comply. Here's kind of a snapshot of where we are today. As I mentioned earlier this year, global warming potential limits were set for concrete used in ready-mix concrete used in buildings and steel rebar used in buildings. And so that's these top two products. But also for all of the products listed in this whole table, even if there's not a global warming potential limit set, we're requiring EPD disclosure starting July 15th. And that's well, I'll show a little bit more about what that process looks like. Yeah.
Would you see this ever expanding beyond state buildings or state buildings?
That would be the hope, that other jurisdictions might also adopt this, and it's also included in new construction. I kind of glazed over because I'm like, oh, MnDOT, because we're focusing on buildings today, but it's also MnDOT is incorporating requirements into their special provisions and their specifications, and they're actually starting to collect EPDs this summer and into next year for concrete, steel, asphalt.
Control like state and county owned roads.
Not all. I think there's like cutoff sizes that they have in the special provisions, which I think they released the updated special provisions. But if you just go to MnDOT's website, or I can give you a contact info if you want to reach out to Emil Bautista and Kurt. They're on the BICLEAN task force, and they're the ones at MnDOT that are kind of implementing a lot of these updates and collecting EPD data.
That's really exciting because they use just enormous amounts of concrete. Yeah.
Yes. So yes, so they're going above and beyond because right now we only have global warming potential limits set for ready mix concrete and rebar in buildings, but MDOT is going kind of above and beyond the minimum like policy requirement and implementing collection of EPDs sooner than that 2028 GWP limit deadline for concrete paving and asphalt paving, which is exciting. Yeah.
So I work for a firm that does nationwide work, and the architects, we submit our own drawings. So I'm licensed in California. And part of the reason why I signed up for that was because with Cal Green, they've kind of like led the way for including within their building code provisions to like for any building that meets this Cal Green kind of requirement. You have to do a life cycle analysis. A lot of the B3 required kind of emissions and product like data information that has to be for all buildings. So I just personal perspective, but having done now work in California, see there to be a definite possibility in code being changed or amended to rather in other states
where certain provisions which now are required for Minnesota B3 actually be within state code.
Mhm.
And that's energy as well as like what Cal Green does.
Did anyone else have another question?
Yeah, there's a question about what that GWP threshold is. I mean, did I
Yeah.
see on the next slide that it was just the national ready mix average? Because that's not too low, is it?
Yes. So yeah, after many task force meetings, kind of hearing perspectives, looking at the data, the available EPDs on the market now for ready mix concrete, that all kind of went into the legislative report, which recommended that our state global warming potential limits for ready mix concrete align with the National Ready Mix Concrete Association's North Central region specific industry-wide benchmarks. And that can be adjusted, every year in the legislative report or every other year. I think at a minimum, it says the task force must meet a minimum of every 3 years to discuss adjusting limits, but that can happen more frequently, especially if NRMCA produces another industry-wide report. Some states like New York, Colorado set their thresholds at say like 125% or 150% above NRMCA's regional average to give a little more wiggle room. We talked this over at on the task force level, and industry said, no way, like we can meet this. Let's do this. Like we don't need to, increase the limit. Like we can definitely meet 100% of the NRMCA's North Central region benchmark. So that's kind of how these limits came to be. And there's more detailed information in that legislative report on the task force website if folks are interested in reading more about that process.
So this is just setting it to what the industry average are.
Yes. Yeah.
Is there intention to set some goals for reducing it?
For sure. And are you like kind of thinking maybe or speaking to like tiers so that if you do better than that, there's some sort of incentive? The way the admin is set up and the buildings are, there's not a way to do incentives for buildings yet. I believe MnDOT does have that ability. And I believe will be setting kind of different tiers to incentivize folks to do better than the average. But this limit, everyone's got to meet this limit. Does that answer your question?
Yeah.
Okay. And again, these are just for ready mix concrete used in buildings. We do not have limits yet for concrete masonry units or precast or pre-stressed concrete. But the hope is that collecting this data over the next 2 years, we'll be able to have a better insight into what those thresholds might be for those products and comparing those to the industry average, seeing if the statewide wants to be lower, the same, higher, just as a starting place. And knowing that the way the policy is written, the limits can be adjusted downward, but not upward. So that kind of that's the starting bar here.
Also, I would point out that the implications for the industry, if you set it at the average, that means half of them are not performing, and there's no way to take an average for a project specific site. There's no way to say, well, I'm getting some that's over, some that's less, therefore the average is meeting. That's not the way it works. So literally half of the concrete producers will not be able to meet this benchmark, and they'll be out of bidding on state buildings. So I think it's a little more aggressive than it sounds, but I think it will encourage some improvement pretty quickly.
But it has to be checked during the submittal process or else.
Yeah.
Yep. I'm actually meeting with the Department of Admin at 2:30 to talk about that process of checking it. Yeah, so you're right.
Silly question.
Yeah.
Why is lightweight concrete have higher GWP than normal weight?
It has to do with the aggregates that go into the lightweight concrete. It's more energy intensive to produce, and I think they have to travel. I don't know the super specifics of it.
Yeah.
But yeah.
Do you anticipate challenges with meeting the disclosure or EPD requirements for CMU and precast
precast in 2026 or?
So that's an exception pathway. So for these other materials where we don't have GWP limits set, it's either because there wasn't enough Minnesota specific data or there's not enough product specific EPDs currently available. So there are industry-wide EPDs for CMU and precast, and then some plants are starting to come online and produce facility specific EPDs. But that's the reason it's at TBD in terms of a global warming potential limit, because there's not enough product-specific EPDs out there right now that we know are being used on Minnesota projects that we can say, here's a good benchmark. There is kind of an exception pathway. As we move along, we're hoping more plants, whether they're ready mix, CMU, precast, are kind of seeing the market indicators of like, oh yeah, we need to start tracking this data. We need to produce EPDs. There will be like a waiver and exception process if there are hurdles for certain products like CMU or precast, and you're not able to get, the manufacturer's not able to get a product specific EPD. In some cases, an industry-wide EPD will be acceptable as kind of a placeholder with a plan of replacing that with a product specific EPD. But generally, we're hoping that, you know, given the EPD market and the way things are kind of accelerating, more market adoption of reporting EPD data, that this will encourage more folks to generate EPDs.
And just to clarify on the previous slide, I think you'd indicated that those disclosures or EPDs for those product types are required starting from here.
Yes, starting July 15th, 2026. Yep. And then these are the limits for steel rebar, carbon steel rebar used in buildings, used in ready-mix concrete, based off of the Concrete Reinforcing Steel Institute's industry-wide average EPD, which I believe included over 150 or even more producers of rebar. The full list is on Concrete Reinforcing Steel Institute's website. But this is the current limit for rebar used on projects.
You'll meet one of those thresholds depending on what the product is reporting, or are you meeting both?
Well, just one of them depending on what the product is reporting. And it's the maximum GWP, like the unfabricated or like the limit at the mill or manufacturer gate is kind of really what the limit is on. And then the calculation for fabricated is just an equivalent number using nationwide average values to get that fabricated limit to compare to EPDs if the EPDs only reporting fabricated and not reporting unfabricated. I think now with the new steel PCR, they should have both reported, but this is kind of a translation in case you don't have the unfabricated value. You can use the fabricated value to meet that limit. Yeah. Okay, and then here is the preliminary submittal process that we're working through, trying to make sure we have this all nailed down by that July 15th implementation date. But basically in pre-design, having teams submit written acknowledgement that they know of the Buy Clean requirements, they're aware of them, that they've factored them into their projects, into their budgets. And then at the beginning, if they know they need to apply for a waiver, say for like an emergency project or emergency situation, they can apply for a waiver in pre-design. Most of the time, I suspect that we wouldn't know enough about what materials we're using on the project to, or have enough project details and specifics about quantities of materials or where they're coming from at pre-design. So waivers are probably not going to happen as much in pre-design unless, like I said, it's an emergency project. And then the Department of Admin recs will review, will collect and review any waivers that come in pre-design, and we'll collect the acknowledgements from the project teams that will be signed by the owner, signed by the design team, and then later when the contractor comes on board, signed by the contractor. And then in design, as you know, the design is becoming a little bit more solidified, teams will identify materials on the project, identify which materials are eligible based on the buy clean requirements, apply for waivers if they know at that point they might need one, and then submit draft specification language outlining EPD submittal requirements for eligible materials. And then at this point, going from pre-design to design, the Department of Administration, Office of State Procurement will then take over kind of review and compliance moving forward in the project. And then our role at B3 is really to verify with the Department of Admin that they've approved and the team is okay to move on to the next B3 phase. And then in final design, that's when teams hopefully have finalized their material selection. They've hopefully confirmed that they can meet the GWP limits, or else kind of shopped around and found alternative products that can meet those GWP limits. And at this point, submit kind of the final specification language that will go into the contract documents, outlining the contractor submittal requirements, including like a schedule of EPDs required to be submitted by the contractor. And then at final design, if there are draft EPDs available, depending on the project delivery type, there might already be that relationship with a GCCM or a contractor on board that has the subs already lined up that might have draft EPDs to send over. That at that point in final design, you can send draft EPDs over. And then also you'll be required to upload a draft of the EPD submittal form Excel sheet. And if there aren't EPDs available, at least estimate kind of quantities of the eligible materials in that spreadsheet. And then again, Department of Admin, Office of State Procurement will review, and then B3 agency contact will verify with Department of Admin. And then finally at closeout, that's when the project team and contractors and subcontractors submit final product data and EPDs via the submittal form. And teams will need to verify that the product data and EPDs provided actually match the as-built condition. Like the information that's on the page is what is out in the field. And again, Department of Admin, Office of State Procurement reviews, and then B3 verifies.
So noticing that different or preliminary criteria only allow for waivers through design and not in final design or closeout. Is it safe to assume that there could be waivers applied in those later stages? Because I feel like a lot of this comes down to construction coordination.
Yes, that's a good point. I think, yes, waivers, we encourage waivers to happen earlier in the design process if you know what materials you have on. But of course, things change in projects. Sometimes later in design, it's out of the control of the design team. And so waivers will be allowed in the later stages. Yes.
Are a lot of your EPDs, like the databases you have in your company, formed by the manufacturer and the reps, or are they informed from the submittals you've gotten on past projects? So like what's actually been installed?
Well, for us right now, we reference a lot of the publicly available EPD, various websites or databases. We're hoping to collect more regional or local EPDs for concrete or things that vary a lot project to project, but I don't feel like we have a lot of data on that.
I feel like too, when we sometimes even publicly available, you can find ones that are like plant specific, but we don't know like as the designer where it's going to come from. So I think there's a verification that we can sometimes go through, but that's not specifically required by a lot of systems. So I'm not sure that we let's go back and do that maybe as much as we've been.
What about you guys? Contractors.
Well, I've got every submittal of every project ever that I had to pay. So I thinking of ways that the back end could inform a database similar way, or looking at the pre-design and design phases where we get involved earlier and earlier projects, like even a pre-design sometimes, where we can identify who the subcontractors would be or what the factory and the plants would be that we would prefer to use to meet those requirements, and that limits our pool for the whole estimating process. So when I'm getting concrete takeoffs, I'm only using the quotes from these two plants because I know they can meet the requirements, or I'm only getting closer to these two subcontractors because they have the flooring I need, that thing. So the earlier I can do that, the more aligned our estimates all the way through, because we're limiting our pool right away and what we're gonna keep.
I think unfortunately, sometimes they're just because of design bid build, right? And you're not selected early on. Hopefully it's just talking to the architect or the structural engineer as to, okay, what was your basis of design? And if they've done their job, then they can be like, well, I looked at, you know, at least these three, right? Manufacturers and products. But I don't know how else in those situations to give you the information ahead of time.
Yeah, it's not always gonna be that case. I mean, I think I've seen some good specs that have all the requirements for all the materials, and those are really good starting points, and then we kind of raise the flag if there's certain things that the industry, or I guess our subcontractors are telling us is a 5x premium on that product versus the normal. But yeah, I will say I'm seeing more and more state and city agencies switching to more of a CM at risk type versus the hard bids. So we're getting a little bit further into the design to help with some of these things. So that's promising. We can leverage that.
And we're getting a little into the wave of the future because I was going to mention this a little bit later, but Built Cold is a database that we will be working with on the Minnesota State side that could potentially address that kind of looking locally. I won't share. I'm just going to mention the Built Cold. There will be like a Built Cold training that dives more into how manufacturers might use this database, upload EPDs directly into it, see other EPDs that are publicly available in like a map view, like say within a certain 20 miles of your project site. And right now it's backloaded with EPDs from EC3. It will be backloaded with EPDs from Emerald Ecolabels tool for asphalt EPDs. And then any other EPDs that get uploaded on a project by project basis into our like Minnesota database with different levels of like viewing access depending on your project admin or contractor or manufacturer. But this is, how does this happen in the future? How do we see predict ahead of like time, like what manufacturers are available that have GWP or have products that meet the GWP limits? And what are the options? And that's kind of all built into the Built Cold. It's like an online cloud platform database, which is really slick, which August 19th, mark your calendars. We haven't sent the invite out yet, but that'll be in person. I think we're going to have it at MnDOT's Maplewood Center. Don't quote me on that. But that's very exciting stuff that kind of, how we effectively implement and integrate EPDs into the design and construction process. Until we get to that point where our database is all built out, we've developed this EPD reporting template. That's an Excel sheet that I mentioned. I wasn't going to dive into the ByClean waivers and exemptions. These are all going to be published on the ByClean website, but these are just some of the reasons why a project team might file for a waiver, request a waiver. I did want to touch a little bit on this carbon budget exception pathway. So it's expected that projects meet the global warming potential requirements for all of the eligible materials. However, say if you're doing ready mix and one of your mixes for whatever reason for finishing for something you're not going to be able to meet that GWP requirement, just within the ready mix concrete category, you can calculate a carbon budget for ready mix, but it can only be within a certain material category that is following the same PCR. That's just an exception pathway that is also built into the spreadsheet that will hopefully get built into the Built Cold database. That's all automated.
Briefly on that. We're doing a LEED project, not a B3 project, and we use this carbon budget on our concrete. There's such a variety of kind of strength requirements and such, and every manufacturer we worked with had great experiences with it. They said we can absolutely meet those requirements, and it was really cost neutral. So that pathway worked exceptionally well with the concrete.
Good. It's good to hear.
Since EPDs have an expiration date priority, I would assume that the database then is managed and EPDs purged when they're expired and.
Exactly. I mean, they're not purged, they just show up with red and says that they're
Oh,
expired,
yeah.
because we're trying to like also kind of like have a
Back history.
back history file for that project moving forward. But yeah, exactly. It's important. That's all tracked within the software. And even kind of looking ahead, there's a built-in tool into BuildCold that's like a market analysis tool that's also looking at when EPDs will expire to kind of anticipate where there might be gaps in EPD data, kind of looking ahead. But yeah, good point. And I won't go into detail on the EPD reporting template. Just that it's got in the kind of drop down menus for the materials and material subcategories, and then manufacturer's name, plant location, product name and description. I think it'll also be important to include like mixed design numbers, because the mixed design numbers on the EPD mean something, but not the designer and the project manager might not know is that the mix that was used on the 4000 PSI, footing mix or wall mix. So that's why this is spreadsheet is important to kind of have that backup, that verification of, yes, this is the mix, exact EPD that was used on this mix that was placed in that wall. Let's see. And I already kind of touched on BuildCold. BuildCold is also, they have had experience working on federal BICLEAN initiative projects and tracking their EPDs and EPD data. They've also worked with the BICLEAN Colorado Act, and have helped Washington State's Department of Commerce build out their database, which they're also collecting HPDs, health product declarations, there. So that there's also that capability to expand for the Minnesota program, if and when that time comes to also start collecting HPDs. But for right now, the requirement is EPDs for these eligible materials on eligible projects. So next steps in the BICLEAN program, as I mentioned, July 15th of this year is when our global warming potential limits and EPD disclosure requirements will be implemented on projects, all projects starting pre-design or bid letting, as MnDOT would call it, will need to meet these requirements. July 15th is also our tentative database launch for the BuildCold database. And then looking ahead, 2026 and beyond on the BICLEAN task force, obviously tracking updates to PCRs, industry average EPDs, industry average LCAs, and any other feedback we're getting. And then also moving forward, kind of reevaluating for the tier 1 materials, asphalt paving, concrete paving, structural steel, precast concrete, CMU, cold form metal framing, seeing where we're at with the data that we've collected, 2026, 2027, 2028, and folding those, that data and analysis into the legislative report that can inform future threshold setting. And then there's this tier 2 of materials, which I didn't mention much, but it's another group of materials that the task force has identified as things we need to look at and think about incorporating for in the future in the policy requirements, and that'll be glass, aluminum, and insulation. And then again, I already mentioned, but January 2028 is when the GWP limits will be set for structural steel, asphalt, and concrete paving. And then I already mentioned the kind of forthcoming updates that are in the process right now, for B3 version 3.2 revision 3. It's a mouthful. One day we'll get to version 4 and leave all that behind. But for now, the current revision that's in process, revision 3, will include that EPD reporting template, and the updated material requirements there. There's also some minor updates to the whole building LCA language, just because there has been a little bit of confusion on some of the projects we've seen come in. And do we also need to include the Revit model that's tied to Tally? Do we need to include the Excel file and the PDF? And it's like, yes, include it. But so there's just a little bit of clarifying language in that revision update, and some other like C&D waste guideline updates. And then looking ahead, like the forthcoming, way ahead, version 4.0, the idea is to, simplify the requirements a little bit, have even more impact, but really focus on whole building LCA tools, maybe incorporating some of those earlier design tools, such as C-Scale, to be able to do LCA earlier in the project. And material circularity, and then health, like I mentioned, like potentially collecting health product declarations alongside EPDs. But that's the future. Got to focus on now. Got to eat, and then we got to talk about how to achieve compliance. Or do we need to do this for a little bit?
Yeah, I was thinking maybe we should take a vote. So the food has arrived. We could eat now and cover what we have left to cover today is this section on how to achieve compliance, which is about 30 slides. And then a very quick Athena walkthrough, and then the kind of the in-person, like working through your own model. So we can do all of that together in a chunk after lunch and eat now, or we can split it up a little bit and do these last 30 slides here and then eat. So how many people want to eat first? One person. So we'll do these slides now. I guess we'll do these slides now and then we'll eat in about half an hour.
Some of us get.
There are snacks still back there. Okay, so there are three paths to achieve the whole building LCA requirements in B3. Path 1, Path 2, and Path 3. Path 1 is the one that's going to be kind of most familiar. It's the whole building LCA approach where you do a model of your whole building. The approved software right now is Tally, Athena, and OneClick. We have talked with Jack about incorporating C-Scale soon. I believe that's going to happen. We're kind of waiting for a version update or something. As we talked about, there's some mandatory kind of settings, if you will, when doing these LCA models to ensure some consistency. One of them being the building service life. Doesn't matter what type of building you're doing, it's got to be set at 60 years. Again, we're looking, this is primarily a software thing. We're looking for software that can do A through C. That's part of the reason why we don't do EC3 or some of these other EPD-based databases or programs that are focused just on the 8 phases. We want to get the whole life cycle. Typically, phase D is being omitted. I think that was originally perhaps copied from the LEED requirements, although I'm not sure what LEED is doing anymore. Do you know?
Yeah,
About phase D? I'm not
I think
sure.
it might be reported separately. They might report
Just
it
a
separate,
separate, yeah.
double check.
I haven't had to do it, but I've never done a version 5, so I don't.
It's usually not a, yeah, I have,
Yeah.
yeah, it's not a good thing to kind of mix sometimes in and out because a lot of times phase D, the impacts from that category are negative. And so they will make your building look better than perhaps it is compared to other projects that have just used A through C. So better not to mix and match that. I also, I had that question earlier about the reference building. So typically we're trying to calculate a percentage reduction from something. We have to have something to compare to. Establishing that reference building is a little bit of a squishy process. This is what we say about it in B3. Okay, they both have to be functionally equivalent. They must both meet the owner's project requirements. They have to have the same function and floor area. They do not have to have the same massing or form. You can change the form, you can change the volume, but they have to have the same floor area. And they both obviously have to meet the energy performance requirements and all the other requirements in B3 and SB 2030. So hopefully you don't meet this requirement by reducing the insulation down to code level, for example, something like that. So when you're doing the modeling here, we'll talk about that a little bit. You want to do the complete building enclosure. That's from the interior finish, typically the drywall to the exterior cladding. You want to include all the structural elements, posts, beams, bearing walls. You want to include the foundation, basement, roof, kind of everything that makes up the enclosure plus interior structure. And for B3, you want to include attached or unattached parking structures on the site. So that can make a huge difference because they're usually site cast concrete, which is really high GWP. And so site or precast concrete. So we want to include those. We want to see how that impacts the overall assessment. The thing you don't want to include is all non-load bearing interior walls and assemblies. So this is kind of a hitch in this process of importing your BIM model into the the LCA software, because if you have a model that has all these internal assemblies, you need to strip those out first. The idea is to really just look at the envelope and the structure. That's really what the LCA, as today, the whole building LCA is focused on. So taking out those interior walls and assemblies, we're taking out interior furnishings and equipment that probably is not in your BIM model, but we don't want to look at those. Electrical and mechanical equipment is removed. And then site improvements, so parking lots or landscapings with the exception of the parking ramps.
Well, parking ramps, but not parking lot.
Right.
What about hardscape?
Also removed. Yeah. Key differences from LEED. I think LEED, I actually did not have time to go back and look at this since the last time I delivered this workshop. So this is 3 years old information, but previously LEED was looking for reductions in a certain mix of different environmental impact categories. B3 program is focused just on the GWP, so we're looking for a 10% reduction there. And LEED has these other options, options 1, 2, and 3, or at least it did. I haven't looked at LEED 5 yet, but those were things like reusing materials or reusing portions of your building. We have not gone there in the B3 program, so right now it's just focused on what you can do with your whole building LCA software.
LEED has an option of just running the whole building CA, but not showing the 10% impact reduction. And for a project that just finishing up right now, with it had to be, again, it was public or private sector, but we were for sure using insulated precast walls, structural and non-structural. I mean, the whole project's mostly concrete. There is no way that we were gonna be able to achieve 10% reduction. So we had to just do the one that we ran through the program. Speaking to precasters, that I'm sure many people have run into this. I asked them if they could modify their fly ash or like some sort of measure where we could reduce the global warming, and they said no.
Yeah.
Period. So it wasn't even like an option.
Yeah.
There's options for the insulation that you use, but that's not typically going to drive it.
With concrete in it.
Yeah.
Yeah. So in those circumstances, you'd have to contact us and we'd work out either a workaround or a waiver. Have you worked on some projects like that? I know they come in once in a while, but So when you're doing a whole building analysis, you have a lot of flexibility in terms of how you're meeting the 10%. So, maybe for this all concrete building we're talking about, you do a whole building LCA, and there might be some strategies up here at the top you could use. Building shape, for example, we know the most efficient way to enclose volume is a sphere. We're probably not building too many domes and spheres. But if you built a box, square box, that will be the better than a rectangle. So you could make your reference building into a rectangle and your as designed building into a box and perhaps get your 10% that way. There's going to be limitations, of course, with site layout and other constraints there, but that might be an option that's available to you if you're doing a whole building LCA. You can also look at things with structural spacing, the grid layout of your columns and beams. You can do all these other strategies that we typically do, like swapping assemblies or swapping materials. You can change your window to wall area ratios. So as long as you're still meeting the B3 requirements for daylighting, or perhaps there's lighting or other lighting requirements, daylighting requirements that you're trying to meet. As long as you can still do that, you can freely adjust the amount of glazing. And glazing has a very high GWP. So if you have an overglazed building, one quick way to meet the 10% is just to cut that back down to a more reasonable level. So that's another thing you can do with a whole building LCA. You can change the floor to floor heights. So maybe you've got some extra height there to work with, and just, reduce the amount of material that's going into the construction. And you can work with structural engineers to, really optimize the use of, the steel I-beams or whatever that you need, the posts and beams and piers. You get a really optimized design that cuts down on material use. Finally, at the bottom, there's these material substitutions. I think this is normally where a lot of us find ourselves working, where, I have XPS. Maybe I just need to go find a different manufacturer for the XPS, or maybe I can swap the XPS for EPS. Those material substitutions are ideally kind of the last choice, the last resort. You want to be working up here, which requires earlier, some earlier work in the design phase. But that gives you the biggest opportunity to hit that 10%. Yeah.
So when it comes to defining that reference model, how do these elements get factored in? Because say you go to a structural engineer, it's like, of course I'm going to design you a efficient system. Why would I give you a bad grid layout that's more expensive and more carbon? How do you reasonably define what these different criteria are without just saying, we could build it as bad as we could build it?
Yeah.
And we're comparing to that. Where is the reasonable threshold? Is there guidance for that?
There is not a lot of guidance. A lot of it's up to your discretion. Do you have any comments about that?
I mean, we'd like to hope that there's a standard of care and folks aren't trying to game the baseline, game the reference building. But like you said, structural engineers should already be designing optimally. So it shouldn't necessarily, I guess you could say, we're changing the grid layout from the first floor to the second floor to eliminate a transfer beam. That's like a discrete thing. That seemed like would happen in design. Whereas, we're going from a 70-foot grid down to a 30-foot grid. Does that really happen? Is that what's reasonable? It's kind of up to the discretion of the designers and the team.
Sometimes I think this takes a really early intervention, but if you're planning a concrete building and there's an opportunity to switch that to steel, bing, you've got your 10% very easily right off the bat. That takes some very early discussions that oftentimes we don't get to. When we're doing this, we come in kind of the whole building LCA is done later in the process, and those kind of decisions were made, months or years ago.
I was going to ask, is it sort of like evidence of your integrated process that you are documenting all the discussions that happened, and went from a mediocre design to a better design instead of engineering after the fact.
Or if you know that a standard building would be done this way, even though maybe, this came up at a previous workshop. Let's say I know that the industry standard is going to be using XPS below grade, but my firm, we've been using EPS for years. Is it okay if I use XPS, which has a higher GWP, in my reference building, even though my firm would never do that? And yes, the answer is yes. If that's the standard, the industry standard, then put that in your reference building.
Also, one of the benefits of using T-scale is that their baseline business as usual. I don't know exactly where they're generating all that information from, but they are going industry standards across the board, and that's how we generate baseline from that.
Yeah.
It's interesting to me that we're allowed to change window to wall ratio and impact some elements that would ultimately also impact the energy performance of the building. Like I know on LEED you have to maintain energy equivalency.
Yeah.
The design options, it sounds like that is different in B3, that you just need to meet the minimum.
Just meet, as long as you're meeting the SB 2030 target.
Yeah, please don't pair those together. It's like complicated enough.
It's where a lot of, I mean, just speaking generally, like buildings are overglazed. So there's a lot of benefits. Yeah.
What she was alluding to as far as
Mixing to.
Yeah, look.
For trade-offs, like better for embodied.
We always try to do high energy performing buildings, but having that kind of metric somehow like proving that throughout the like LCA project, that would be hard.
Not sure I follow, but
it's okay. We can move on.
Yeah.
You mentioned like you can change building shape. Is it like you can have reference as triangle and then have the my question was like, would that still meet the floor area requirement that you said matches, and then also
as long as the floor area is the same. So you could set your reference building if you know most of the buildings you do are maybe they're a U shape or something that's a little less efficient. But in your case, you're designing a building that's a square, then your reference building could be this U shape, and you probably get to 10% savings just on the shape alone. Just the efficiency of your enclosure. Again, like Natalie said, if you're not usually building a building like that, there's a standard of care. Like we're asking you not to just, I'm gonna make my building into a W or something crazy.
it's not like monitored on your end?
It's pretty hard for us to monitor. I'll be honest about that.
I think, having done a lot of energy models, that baseline is a lot more prescribed, but still fought over all the time. The thing that you should do with this is start with your design as much as you can, rather than starting with what your design is and getting to 10%. But within that, there should be design decisions that you go through in the process, ideally, that get you to 10%. 10% is not that much if you're considering all these categories.
Yeah.
Unless you have to have unless you have to have a lot of concrete. It was basically the big obstacle I gave.
Yeah, like if you have a Minnesota State building, the expectation is that you're using masonry. So it's hard to move that goalpost very much when they have very prescribed standards that you have to abide by, or even by building type. Like I've done a building where it was kind of a warehouse like facility, and it's really hard to get that 10% out of a building that has to have a very deep floor plate. So your structure has to be a certain thing. Your wall assembly wants to be a certain type of wall assembly. And how do you get that 10% eked out of a building that kind of just already has a very
you get worked further and further down this list, and eventually you're scrambling to find an EPD or a concrete manufacturer that can help you get there.
Yeah, and also if your base model too is, I guess the point that I was trying to articulate and didn't do very well. If your
if the owner is requiring, basically your base building to be very high performing, across like energy metrics and that does have an interface then with,
LCA.
yeah, with
Yeah, for
LCA,
sure. Yeah.
then eking out that 10% can be really difficult. Yeah.
So I think this seems like a pretty experienced group. I'm gonna kind of breeze through these. But I wanted to just give some examples. So this was the Itasca Biological Station. It was a super insulated, high energy performance building, wood frame though. And so we ran some LCA analysis for this building. And we're able to achieve this, this reduction. Here was the baseline. Here was a design version of it. In this case, this is what was built. And so we were just testing the feasibility of getting to this 10%. And what we found was that it was possible. The main things was an optimization of the concrete slab. They had specified 5 inches. We determined 4 inches. Slab would be probably enough. And then they had a wood truss attic system. But they had completely covered the roof deck with like a bitumen membrane, which was a little bit of an overkill. And so when we replaced that bitumen membrane with 2 layers of roofing felt, kind of a more standard roofing system, and also swapped out, they had used a lot of spray foam. When we made those material swaps, we were able to see the reduction here. Another one we looked at was the Wells Fargo office building. So this was a concrete frame building, 6-story office. And as built, it was site cast concrete posts and beams, and then it used precast concrete floors. So we ran a number of different models on that. This was the base case office. We tried, this was all done in Athena. And so we increased the fly ash percentage, and that had quite a dramatic effect. We tried replacing the site cast with precast columns. That also Athena was saying that would have a large benefit. And then this is what it would look like if you could build this building with steel structure. So those were all of those scenarios could have achieved the 10% reduction.
Even with fly ash, like our structural engineers, like, do you have 30% or something?
35%.
35, yeah. They won't go beyond that, I'm not sure if there's technology to support that, but at some point these reach kind of their limits, right?
Yeah.
In this one, is it saying that the precast, and it is saying that the precast is lower in GWP than the site cast with fly ash? That's generally the case.
That's what Athena. Athena puts them pretty close. I don't know. Do you?
I mean, it's probably due to maybe waste or efficiencies of having something cast already on site and kind of having that dialed in and having it be modular. That would be my guess. But of course, I don't know. Does this take into account transportation?
It should.
It should, yeah. But I would think it's just at the precast site, kind of having everything, all the experience, having all the same exact size beams, columns, rebar, kind of pumping those out. I would think because there's more control there. There's less waste. It's more efficient process than on site.
I was looking to see if you can try so hard to get fly ash or other substitutions in precast, but we didn't even think about comparing it to site cast. So it's a good reduction.
Yeah, and some of these, to be honest, they're going to be, if you used a different tool. This is going back a little bit on what I said earlier. but maybe you wouldn't see that equivalence in Tally. Or if you're really zeroing in and uploading EPDs for your specific mixes, you might not see this level of equivalence. But Athena is pretty rough.
Yeah, as far as sidecast too, like we couldn't do sidecast. There would be no space, for all of these panels too, but it is good to know.
Precast makes sense.
Yeah.
Do we know that the precast doesn't have fly ash in it, right? It probably would because it'd be more control in the environment and they can longer curing times. One of the reasons why you wouldn't have fly ash in sidecast because of modern curing times. Maybe they just have more control in the process. They are incorporating.
No, I found that for precast, they didn't have any. And they weren't willing to put it in.
It's such a structured schedule, to push them up so quickly that we're went to the fire so long.
I also recently ran into challenges with precast where we were asking for EPDs and trying to get lower carbon precast. And they said, we have an EPD, but we can't customize it to the specific mix we're putting in precast. And they said there's a limitation of the PCR, if I remember correctly. So I wonder with all your PCR contacts that there's like thinking about adjusting that to enable more customization. It's not something I'm very educated on, just passing along what I heard.
Well, we do, I mean, part of the Buy Clean program was or is a grant program to manufacturers to help them develop EPDs. I may have been out of the room if you mentioned that, but.
No, I didn't mention the grant program, but that's been going on since April of last year. And the Aggregate Ready Mix Association of Minnesota has been working with a lot of local manufacturers and producers. I believe some precast, maybe Knife River, some other facilities that do precast and sidecast. And I think the EPD infrastructure, data infrastructure is evolving, developing. Hopefully the grant is helping to kind of at least kickstart that. And then we're hoping to do a second round of grants because there is still more money left from that grant program to do another round of EPD generation and getting plants set up. Because once you get set up with the tools and the base data, it's kind of like updating, tweaking, to produce. If you like tweak your mix and now you're doing 20% fly ash, you can just type that in as long as your base information for the fly ash was good. It's just tweaking quantities and the program can spit that out and get you a third-party verified type 3 EPD relatively easily and relatively low cost. But I think there's a couple different tools on the market depending which EPD software or producer they go with. It's a different process, but there's resources from Aggregate Ready Mix Association of Minnesota on their website for plants, precast or ready mix to get involved, to get information. There's trainings going on to get to know who the different LCA practitioners are that you would work with to kind of get started tracking that information at your plant and then maintaining EPDs and creating new ones. So there's a lot kind of going on to hopefully, kickstart the EPD data infrastructure in Minnesota. So hopefully we'll see more EPDs, product specific, mix specific EPDs for precasters.
I think the more you're asking those questions on a project, like it might be really frustrating that you can't get it on that project, but you're indicating to them that if they made this, it would be in demand in your next project or someone else's might get the reduced option from that same person. It's more like the advocacy side, which takes time, but doesn't help your immediate project long term.
That has been part of the goal of the B3 program, and the reason we ask people to submit EPDs has been that show that there's a demand. I think this is one thing that I've been harping on. We want full building LCA to happen early as more and more of these tools get linked in with BIM software. I think many teams decide to wait until the BIM model is completed or at least well underway, because then I just one click and I just import my model and then I don't have to do all these takeoffs. that is a problem if you're doing whole building LCA because a lot of the best savings are occurring very, very early in the project. So ideally, we're not doing a program that looks like I'm worked through schematic design. Now I've got construction documents and I've got my completed BIM model. Now I'm going to import it and do a whole building LCA. That is unfortunately what we see a lot of times. This is the process we're looking for. Natalie mentioned, the upcoming updates to the B3 program where we're going to try and make this more built in. And so they're not just submitting a whole building model at the end and saying, oh, I met 10%, but really like, what are you doing upfront during the schematic design phase when I could perhaps switch structural systems or change the form of my building to encourage more of those types of strategies. And that's going to take a different mindset. The architects have to work with the structural engineers, have to work with the project planners to make sure that things fit on the site and I can change the size or the shape of my building and things like that. But
it might also mean just using different software programs at different times. Initially,
yes. Yeah.
I mean, you can make the case to your project manager or your whatever principal, like I need to model this in essentially not Revit initially,
Yeah.
because Revit kind of forces you to model, and you don't want to remodel certain wall types or certain, slabs, right? It's kind of like built into the modeling file.
Yeah, so that's one reason that I've liked using Athena because it's such a simplified program. You really don't even need a building design. If you want to just start playing with 100 square feet of wall area, you can start making those changes or just try different structural systems on, 1,000 square foot grid and see, start getting a sense really early how to achieve these savings. A lot harder to do with a complex program that's integrated with BIM.
That kind of forces you into a level of specificity that you don't necessarily want when you're doing LCA at, say, schematic.
Exactly. Yeah.
We just clarify though, we shouldn't be using two different ones. We shouldn't do Athena at the beginning and Kali at the end.
You can, but you just don't want to compare the results. But you can use a different software up front. Like we also discussed how they're all going to probably give you the same direction. Like, oh, I could use precast rather than sitecast, or I could use, I think the earlier example we were looking at was a different PSI of concrete. So all of the tools showed that as the PSI decreased, the GWP decreased. So they're going to provide consistent answers that give your team direction on what strategies to pursue. You just don't want to, at the end of the day, compare, this was my carbon number per square foot that I got from Tally, and now I'm going to compare it to the one that I got from early on from Athena. You have to get the 10%. But yeah, at the end of the day, that 10% is shown at the the final design phase of the project. But all these decisions are being made earlier, I think.
So I have a question. Sorry. We submit a schematic design, but you can't have a reduction in square footage. And I think we would all agree that your buildings get smaller as they go through design generally due to value engineering. And so if we submit that initial model at schematic design, our building gets reduced in square footage. How do we suss out if that building, if our initial reduction was shown at schematic, our initial baseline was shown at schematic design, do you have to go back and then
you'd have to redo a reference building? And that's the same thing you have to do in the energy modeling.
Yep. The energy modeling has ASHRAE standard 209 now sets different levels of detail for different phases that you're at, and this gives me a lot of similarities here. The ST analysis doesn't have as much detail. Its outputs aren't as relevant, and then when you get to CDs, you do have to make that reference design in your CD. So within whatever your final package software you're using, you need a reference design. that is reflective of not just the decisions you made along the way, reduce square footage, but now we have the final design. What would the reference design be for that building?
Sure.
Was there a question? Yeah.
Not a question, more of a comment, and that's where I'm not being paid by T-scale, but maybe this is another reason for using it is that if they're drawn from the same database, if Pally and T-scale are drawn from the same database, maybe there's a reason for incorporating this. T-scale for your upfront analysis, your schematic design, is going to be the same concrete, 300 PSI concrete is going to be the same in that as it will be in Pally, down for later DD evaluation.
Yeah. Yeah, thank you. So this is just, I'm not going to talk about this, but if you want to look at it more in detail in your PDF, you can. It just talks about all the various things you can do through the stages of design. When should I be looking at the structural system? A lot of it's kind of self-explanatory if you're an architect and you've been through this process before, but it was a nice graphic that laid out all the steps. Whole building strategies, obviously earliest. Structure, still very early. Envelope, schematic design, 50 or 100%. So path 2 is similar to the whole building approach, but it's based on structural bays, where you're modeling. I'm going to skip ahead just a couple. You're modeling basically a slice through the building instead of the whole building. I think it's an approach that works very well at the early design stages when your whole building might still be in flux. But you're trying to narrow in on the structural systems and the enclosure systems. The requirement is the same, 10% reduction in GWP. You still have to have kind of a reference case to calculate that against. The modeling requirements are the same generally as path 1 in terms of it's still a 60-year building lifespan and that kind of thing. But now you're modeling a slice through the building. So the way our program is set up is it's not just a bay, it's a literal slice. So we're getting enclosure at the front and the back of the building, as well as at the top and the bottom. So the enclosure has just as much and sometimes more to do with the whole building LCA result as the structure does. So we want to get plenty of enclosure in that we call it bay, but it's really more of a slice. So that's what point number 2 is getting to. It should
do
yeah.
slices through all of your various then envelope systems.
No, you don't. I would just pick one that's maybe most representative.
Oh, okay.
Yep,
That's cool.
and use that.
Okay.
Yep. If you have a building that has 2 radically different structures, like some portion of it is precast concrete warehouse and the other building is like an office with steel frame, this wouldn't be a path you could use. Yeah, so whole building slice from top to bottom, front to back. This picture is not showing that because this picture is what we're going to be doing later, which is a simpler version. But ideally, it would extend through all the way through to the back side of the building, so you have more enclosure there. This time, there's really no way to incorporate an unattached parking garage or even really a parking garage. I don't really know. I can't remember how this decision was made, but for this model, parking garages are not included for this path. I'm sorry. That might be something we need to revisit in the B3 program as we're updating these requirements, but you can go through this without including your parking garages. Now, when you're working at this level, there's some early design stage strategies you don't get to take advantage of. You can't really look at the building shape anymore. You can't really look at sometimes even the structural spacing and the grid layout because you're confined to kind of one bay. wide. So there's some strategies that don't work. But overall, I think there's still many that do. So it's still an effective way, and it allows you to get in there and start working on the building, the whole building LCA earlier. Skip this. Okay. Path 3 is the simplest path. Oh, I should have said though, historically, part of path 2 has been you can do all this work, but at the end, we still want you to submit a full building LCA analysis. I don't know if that's going to stick around. It kind of really discounts the value of doing this approach if you do this and now you've also got to do a whole building model at the end. That has been a thing that the B3 program has historically asked for because we had interest in developing a database of whole building models. We have found that that database is just not enough consistency, modeling consistency, to be very useful. So we'll be looking at making this simpler and eliminating that step, but that is all going to be discussed coming up. Path 3 has that same limitations. It's a really easy Excel calculator, but again, whole building LCA model at the end. So historically, that's been what's asked, that has been the kind of the process. However, if you're a small building, how many people know the B3 small buildings approach? Okay, it's basically if you have a building that's 20,000 square feet or less, there's going to be some guidelines in the B3 program that are simplified for you, and this is one of them. So if you have a small building and it's under 20,000 square feet, you can use this calculator that we'll look at in just a moment without having to do a whole building LCA model. However, this calculator approach is the most restricted in terms of the strategies you can use. It's really just a material substitution. So I'm picking XPS versus EPS, or I'm picking closed cell foam versus open cell foam. That's the level that we're working at with the calculator. So all the other strategies, you may not be able to meet it, meet your 10% or meet the B3 guidelines without all of those strategies available to you. So sometimes the team will try and use this approach. They find they can't meet it. They've got to go back to the whole building LCA or a structural bay approach. Also, this is not a building that you can, or not an approach you can use on a building with a lot of different structural systems or enclosure systems. So we're supposed to pick, you're supposed to pick a system here when you're working within a system. You're supposed to pick the system that at least accounts for 60% of the building surface area if you're talking about cladding. So if you have a building where there's 3 different cladding types and one is at 30%, another is at 30%, and the fourth is at 40%, this is not an approach that you can use because none of that rises to the level of 60%. We're looking for something that's more than half. So there is that restriction as well. So that's, you kind of get narrowed down. The number of projects that can use this path is definitely smaller. But at the end of the day, these are the areas, the different material categories that you can work in: cladding, roofing, low slope roofing, pitch roofing, columns and beams, exterior wall, structural material, various types of insulation. So it's very focused on insulation. If you don't have, for example, cavity insulation in your building, then those categories are just removed from the calculator. And the goal is to get a score that the calculator gives you under 1.65. And we'll take a look at how that's generated in just a moment. think the next slide is start. So when the calculator was built, we basically just did a complete data dump from Athena. And so all this is based on Athena database entries. We have for the cladding, this is all the different types of cladding they had in Athena at that time. And then we graphed their global warming potential and categorized them into different groups. So group 5s were given 5 points, group 3s were 3, 2s, 1s, etc. And so the idea is to just work your way to the right towards those group 1 options. And again, you're not going to have the ability to do that on every building given the constraints of the design or the project requirements. But this is kind of an interesting cheat sheet, I think. It's one of the reasons I included in the presentation. If you're ever wondering, they're sitting there trying, typing away and saying, well, I don't know if stucco is better than, metal panel cladding, you can go back to this slide and at least see what Athena thinks. Here's stucco, here's the metal panel. So maybe it's not going to be absolutely correct for your specific products or materials, but at least it gives you an idea of the relative impact. And you can just kind of flash through these. This was cladding. This was low slope roofing. This is columns and beams. So again, all of these things are stock types in the Athena database. So we have 2-ply, built-up roof of 4-ply, PVC membranes, TPO and EPDM membranes. So a lot of the membranes you can see right off the bat are going to outperform the traditional roofing, the built-up roofing. In terms of columns and beams, this is what we're coming back to multiple times here: concrete site cast, precast, steel, wide flange, and then finally wood. So for exterior walls, these are the options. They've got concrete site cast, concrete tilt up or the precast, CMU, galvanized steel stud, and then finally wood frame. And then some insulation products. So XPS, really, this is based on the HFC blowing agents. I believe that has been improved somewhat since these results were compiled. However, Minnesota is not one of the states that's put GWP limits on XPS. So the availability of the low GWP XPS foams is kind of on you to go out and find that. You're not just going to be able to assume that whatever arrives at the job site is low GWP. We do have a process. So if you know that you're going to order a low GWP XPS and you're trying to use this Excel tool, you can email us and we'll give you permission as long as you can show us evidence that you're going to get a low GWP XPS. We will let you use swap that out for EPS in the calculator tool. This shows the same thing with closed cell spray foam. Again, the blown with HFC blowing agents here. That's very, very high. This is just a little bit more detail on why those have been so high. XPS and closed cell spray foam. Originally, a lot of this graph gets confused with the ozone depletion potential oftentimes, but the GWP is a separate issue that has not been as well, attacked. That problem hasn't been attacked as well as the ozone has been. It is getting more and more attention now. So as the blowing agents are going from 2nd to 3rd to 4th generation, they're now starting to pay more attention to the GWP. The ozone depletion potential was reduced a long time ago, but that GWP is still something that can fluctuate wildly depending on what the blowing agent is specifically in your product. So yes, there is. This is just you probably are already familiar with this from working in the field, but there are some options, XPS options with low GWP. There's Foamular NGX. There is reduced GWP styrofoam, and there's Green Guard XPS. So if you can find those products, you can use EPS in this calculator rather than the XPS. Also, closed cell spray foam. The Solstice LBA blowing agent is the one to use. There's a lot of proprietary foam companies that have developed using that Solstice product. They've developed their own products, heat lock or foam lock or whatever it is. But that is something you've got to track down and make sure, because again, it is not regulated in this state. Yeah.
I know that nationally there were restrictions now on the blowing agents.
I'm not sure nationally, but there is certainly states. There are some states that have put restrictions on, and we're just not one of those. Does anybody know more about that?
Yeah, I think California.
California. I think there's a handful of them. There's like maybe half a dozen or a dozen states that have put limits.
These products are a lot more available, so they're doing it voluntarily.
What I do with specs is under like first group all the property characteristics together and then include like GWP and specifically say what you want.
Yeah.
Like shall not exceed, whatever.
Right. Let's see. Okay, so for the Wells Fargo office building, going back to this example, we just got a few more slides to go here. This is a view of what the calculator looks like. As designed, it had a lot of category 5 materials. It was using XPS in the wall and the roof and below grade. It was using built-up roof for the low slope roofing. It had metal panel walls. It had concrete site cast beams. So a lot of 5s across the board there. So the score was close to 5. It was 4.25, and we got to work our way down to 1.65. So this is just showing an example of what you have to do to get to that level. The below grade insulation becomes EPS. The roof insulation becomes polyiso. On the walls, it becomes EPS or polyiso. The columns and beams material goes from site cast to precast, and the roof goes from built-up roof to EPDM membrane. So if you can make all those changes, oh, I'm sorry, I forgot the cladding too. So the cladding went from metal panel to fiber cement. Again, all of those may not be on the table for you, given the project requirements and constraints, but that's kind of a level, it's just showing the level you'd have to go to meet this, the score here. It's pretty aggressive. So not every building is going to be able to do that, in which case you've got to go back to your whole building LCA models and find other ways to get the 10% reduction.
I assume that there's some sort of weighting of the various systems that's going on in the background when you input, or no?
There's not really.
They're all treated
There's
the
not.
same.
They're all treated the same.
Threshold, so this is most.
It is supposed to be most of your building, but yeah, there's not a complex weighting. It's very insulation focused.
Yep.
And
there's obviously more, whatever. Okay,
Yeah.
there's no weighting.
right.
Okay.
No square footage is entered.
Yeah.
Yeah. And so we this is one of the things that might go away at the next iteration when we update the requirements. But for now, this is what we have. Any other questions? And we can break for lunch. Yeah.
The charging for that Rockwell was pretty comparative to
Mhm.
other installations.
Yeah. Does that seem weird?
What if it gets such a bad rap in some of our lesser
Yeah.
That chart showed that.
Yep.
It still works.
It's still twice or three times higher than fiberglass bat. But like Rachel's saying, you have to really zoom in. It's just when you look at this in comparison to some of the other foams, you know.
Put some FPS on the chart.
Right?
Because this is a E3 spreadsheet, you're interested in considering integrating some of the newer products online, like timber HP, wood capture, wood fiber insulation. Like what sort of impact that can have?
Yeah, I think we would be, except that there hasn't been much interest in updating this because it's gonna probably go away.
Okay.
So
Maybe it did its job though,
I
right?
think, yeah, generally it's supposed to be like a learning tool.
Yeah.
So it's a quick way, rather than spending a lot of time coming up with takeoffs and developing whole building models, you can work through this and figure it out really quickly. You know, if you're looking at just material substitutions, what's going to be better and what's going to be worse. So it's really more of a learning tool. Yeah.
Maybe a bit of a comment, then more or less a question. Like, I don't think any of these modeling softwares will capture the other impacts outside of the materials themselves, like timing and the construction process. Like, I'm thinking about if we did all this casting clay stuff on the project, which is coming from Lawrence and there's a lot of depth to this concrete. It could be quicker for me to pre-fab a bunch of metal panel walls and slap them up on a building, which means I'm on my site less, I'm doing less construction. I'm reducing the time frame of all of these things so that the overall sustainability story can change a little bit, but it's not going to be captured because my metal panel is made more. Those kinds of things, but I think that's just something else to consider if you talk about this, where a certain product or a certain assembly type may add 50% to the schedule, which means I'm just dragging out all these other processes instead of I could reduce the whole project schedule.
Yeah.
Or reducing a lot.
Yeah, it's a good point. So technically these results should be incorporating the construction impacts. But as you're saying, the construction impacts can vary wildly, and there's no way the tool is going to know that. So.
And then I think this is it's been a very long. We're pretty blessed in Minnesota to have a lot of local high quality stuff available that other places don't.
Yeah, thanks. Any other questions?
That obviously this wouldn't necessarily apply if you've got a certain reporting body that you can for your project, but I think in another case like that, you have an owner with sustainability priorities. I think, you know, if you've got your own tracking going on, or if there's a way to like help craft that narrative and like convey the information specific to your project, like I think there are still ways for people to make sustainable decisions and defend on a project that a client will support that might not necessarily reflect in the standardized documentation that we would have to follow for this. So I think putting those things on the table, you know, maybe it's a voluntary program that they're doing. Maybe they do take interest in some cost savings and the construction side of things. But yeah, the more tracking and discussion I think that goes on, the easier it is to pitch that approach.
And the more data you can collect. Because I think, you know, on the skimpy side, you're just ending up with, you know, kind of another label, like mine's local. So the more data you can collect behind that to show I've reduced it, you know, by 45 days, and this is what my expected emissions are of operation of construction per day, that's going to have more buy-in than the other.
Yeah. Well, we are starting to track that at our level of like this project, this location, many people driving this far, like those are some data points that we're starting to collect so that we can put a metric to that. Rural North Dakota is going to get those versus city.
Yeah, that's great.
Didn't Scandia do some like studies about tracking vehicles, like how many times they would need to go across a site to rough grade and then to finish grade? And there was this
study done where, depending on kind of what essentially your built on site elements and how much truck or vehicle traffic was done would yield, yeah, a certain amount of pollution. That's all I remember is like Scandia did some of that work, along with what, carbon.
There's also a contractors commitment out there. I think there's a growing number of contractors. More right. Who are tracking it. So I would say whoever you're working with and ask them to see what they're doing. And if they're not doing it, then tell them about the contractors commitment and that'll give us some guidance on how to move forward with it.
Thank you. Okay. You'll get to learn it better as you're working through it on your own, I think. I'll show you a few key things though. And then I do have a little PowerPoint that I realized I should have sent out yesterday that has your assignment or your problem. So I will, as soon as I'm done with the walkthrough, take a few moments to email that to you. Does everybody have their email working? Okay. No.
But that's cool.
Maybe you can share with Sarah. Yeah.
A thumb drive? You not a thumb drive?
Of course.
So that PowerPoint just has kind of the specifications for the model that we'll be modeling together. So, or you'll be modeling on your own, I should say. So you can use that PowerPoint, kind of flip page by page and follow the instructions on there so that everybody is modeling the same thing. And then when we're done modeling that, we'll get back together, we'll kind of compare results.
Yeah.
And then the next step will be to go back and take that model and try and get a 10% reduction. So you're free to try various strategies that you come up with based on what you've learned in practice or what you've learned today, and see if you can hit that 10% benchmark. So that's kind of the last thing we'll do. And hopefully if there's enough time at the end of that, we can get back together again and kind of talk about what people found. So first thing is the walkthrough here. Everybody have Athena open so far? Unfortunately, my Athena has been a little bit laggy and there's points where it looks like it's going to crash. So hopefully that doesn't actually happen, but we may have to hold on for a minute or two at some point here. You've got yours working.
I don't know if it's.
Yeah, well, maybe if mine gets bogged down. Okay, so the first thing you'll do is you right click on the impact estimator line and you'll see an option to open a project or start a new project. I will talk about these in just a moment, but right now let's just start a new project. And like I said this morning, the first screen that comes up, you have a chance to input your building life expectancy. You'll see it's already set to 60 years. You can choose a project location. So the idea of the project location is some of the data in Athena database has location information. So it will try and estimate, the shipping or the trucking distance to your project site. You can select the building type, commercial, industrial, institutional. I'm just going to do a single family residential for this. And then you select building height. So I'm going to say 20 feet. Oh, I'm sorry. I should have mentioned units. So usually when I open this up, the units come in as SI. On this screen, you can change it over to imperial right here. And I'm going to make the floor area 1,000 square foot just for simplicity's sake. And I click OK. Okay, so it started my project here, and what it's gonna do is basically build a tree structure, starting from your project and working down to gradually working down to more and more specific items. If you now right-click that project and scroll down to add assembly, you'll see the different assembly groups we can add. I'm just gonna start with foundations because that's pretty easy, and you see the options here. We can do concrete footings. I'm just gonna call it footing. And we can say the length might be, let's say, 100 feet long for this building.
Can you go back and
Yeah.
how you get to that,
Oops, geez, that's
that
loud.
window? I wasn't asking you.
Hey, Ralph, can you go back?
Yeah.
So did everyone create their new building and put in the? Yep. Okay,
Under tools?
and I think you just right click the building, right?
Yeah,
Add it
I'll
to
be
the-
there in just a moment. It's not gonna let me get out of here that easily. Um,
Okay.
okay, yeah, so you just right click the project line. It should have a P, and you can scroll down to add assembly. And I clicked on foundations.
And then you choose your,
I did concrete footing first. Yeah.
all right.
So I added my footing. Now it's not imperative that you guys keep up with every step here. We're not going to be using this model again. So just try and follow along as best you can. The next thing I might add would be the concrete slab on grade. So I'm just going to open that and call it slab. And you can see how Athena starts to guide you through the inputs here. And let's say it's 20, 35. And it's got inputs for you that, you can't really adjust. So you're either going to end up with a 4-inch slab or an 8-inch slab. There's ways to, workarounds. Obviously, if you have a slab that's 6 inches, maybe you put in half of your slab at 4 and half of your slab at 8. But you'll find yourself doing a lot of workarounds like that, the more detailed you try and get. I find that Athena works best at the very early design phases. So the importance of getting it absolutely right is probably not very high at this point. So now I've got a slab and a footing for my foundation. I'm going to skip forward a little bit and add a roof. So you can see the different roof assemblies here. Let's say, oops.
Or go to, yes, sure, custom.
Let's see, for my wood house, I'm gonna do wood joist. Roof. And the roof width is again 30, the span is 20. It's got some OSB decking, so I'm going to change it to OSB rather than plywood, and I'm going to specify the thickness is 1/2 inch. You can do the live load.
So there you go. So you questions that normally gives. Well, let's give it a form. But what's the length? One? Yeah. Sure.
Ben, what's the happening?
15, yeah. Okay, so you see the numbers that are starting to populate to the right side. How many people have those numbers showing up? Not many yet. So the way to get those numbers is to go back to the top. I right click Impact Estimator. So these are some of the settings. And you can go down and click Show LCA Measure. And then you can select what measure you want it to show on your tree. So maybe it's ozone depletion potential, but maybe, well, I'd really rather see global warming potential. So I select that, and now you see it's totaling the number of kilograms, in this case, of CO2 associated with each one of those components. Yeah, so you can also, if you select this top one here, just above the measure, you can change it between values and percent. So that's going to give you a quick eyeball on, what different, the hot spots we were talking about earlier.
For the unit, if we select an imperial, like what are we getting?
Yeah, there's a few quirks like that. So even if you set it to imperial, there's going to be something that still show up SI. Yeah. Now, if you guys have been going exactly along with mine, you might notice why is the roof negative here? And why do I have 128% up here for foundations? So this is where the biogenic carbon in wood is coming into play. So the biogenic carbon is this carbon that's stored in wood, basically, and it's giving you a credit for that, which is negative. It's showing up as negative 28.77%. So it essentially reduces the more wood you add, the more your carbon footprint is reduced, which is a little bit unfortunate. We have tried to work around that by just specifying phases A through C. Usually the biogenic carbon is part of phase D. But this most recent version of Athena, for some reason that neither Natalie or I are really clear on, some of that biogenic carbon is associated with phase A through C. So you're going to see oftentimes negative carbon associated with any wood product that you're inserting, even if you skip phase D. So that's the background on why this is coming in negative. Continuing on here, I wanted to add some walls. So if you scroll down to walls, you pick custom wall. We'll call this foundation wall. Make it 50 feet long and 10 feet high. And I'm going to say it was made with concrete block. So you select the concrete block and then you click add. And it gives you a few details. And normally you'd see a few more options than this. I guess for concrete block, they've only got 8-inch CMU. So we'll just go with that. And now we know that, okay, so I have a concrete block wall, but let's say my basement is finished. So I might have actually a second wall in that basement, which is a wood stud wall. And I can add the wood studs. Now there's a few more options here. So let's say there's no sheathing because it's an interior wall. It's non-load bearing. The stud spacing is 24 inches, just 2x4s because I'm framing out a basement. So I can add that. So now I have a wood stud wall inside of my concrete block wall. But I still don't have all the materials in that wall assembly. So once you've added the basic wall types, you navigate up here to the tabs on top. You can click envelope, insert, and it opens a whole nother kind of window dialog box where you can start adding the additional layers in your assembly. So I'm going to leave the assembly group as walls because we're working in walls. But I'm going to say, okay, it does have cladding. I'm going to say on the outside is stucco. And so I'm going to add some stucco on the outside of this wall. And I know that on the inside, there's probably some gypsum board to finish it off. So I can choose different types of gypsum board. I'm going to add that. And maybe this basement was done by an ill-informed contractor who thought a vapor retarder would be a good idea. And so I'm going to add 6 mil poly. And so now I have a vapor retarder in my wall assembly. So you see how I'm just kind of building up the wall assembly layer by layer. When I've got that all kind of squared away, click OK. Just going to think a little bit.
I think that doesn't have this capability where you can like pull information, where you can customize it, does it?
It does.
It does? Okay.
Yeah.
Maybe
It's,
I just
yeah.
understood.
Okay, so now we can see under this foundation wall option, I've got concrete block and wood stud associated with my foundation wall. I can go back up to the walls and add another wall. Say I call it my above grade wall. I'm gonna make that, and I'm gonna give it a length of 100 feet. Height of 9, and this is gonna be a wood stud wall, which I'm gonna add. And now it's 2x6s. It's got OSB sheathing, and it's load bearing. And now I've got a chance to add some openings above grade. So I'm going to say it's got 2 windows in it. It's a very dark house. And 1 door, and you can specify the size of the door. We can specify the total window area. So I'm going to say is total of those 2 windows is 15 square feet. You can select whether they're fixed or operable. I can select the frame type. So since this is just a normal house, I'm going to say it's a PVC window frame and double glazed soft coated argon window. Maybe it's like a Energy Star window or something like that. And you'll notice it does get pretty specific about what type of glass and what kind of window frame. That's because the windows are pretty impactful in your results, at least for global warming potential and embodied carbon. So glass can make a big difference.
I didn't see it. Does it list like some low E coatings and stuff?
It does. Yep. Yeah. So you get a variety of different options there. And now, so as I'm adding windows, one thing I've had to go back and verify is that as the surface area of the windows is increasing, it's reducing the area of the wall that you're inserting it in. So it's smart enough to make that calculation for you. I'm putting this in a wood stud frame wall. So it's going to start reducing the amount of cladding. It's going to start reducing the amount of rough framing. It's going to reduce the amount of drywall that this wall is associated with because of that window area. Okay. So now I have some walls, roof, foundation. I could continue to go through here and create my complete house. I'm not going to do that. One thing I wanted to point out, though, was there's going to be some cases where the material or the product you want isn't in any of those drop-down lists. So if I right-click a wall or right-click a roof, and I scroll down here to add assembly, you're going to see this option for extra materials. So if I click on extra materials, it opens up the complete database of materials. And I can try and find somewhere in Athena. If Athena has it, it will be in this database. So maybe I just couldn't find, I wanted to add some clay tile to my basement slab for some reason, and it wasn't in the slab drop-down menu. So I could go here to the extra basic materials and select clay tile and add that. And now I can just enter an amount. I have to create my own estimate. Let's say it was maybe 500 square feet. And you'll see it has a construction waste factor. So when I click OK, it's going to multiply that 500 square feet by this construction waste factor, and I should get something over 500 here. Okay, 535 square feet. So now I've added clay. It looks like I added that actually to the wall. And when I look at the reports, that clay tile will show up under the walls category. I could have added the clay tile. I was talking about adding the clay tile to the foundation. So let me just do that instead. No, not easily. You can duplicate the different walls, and I'm sorry, maybe not. Let's see. You can duplicate projects. Let's see here. There it is. Okay, thank you. Yeah. So I could make multiple copies of that. I could also so this is handy for creating a reference building. So if I go up here and select my project file, I can duplicate the project and it creates a copy down here. And then I can open that tree structure up and start manipulating things down here in my copied file. So I could make a reference building, or I could have made the reference building first and start making my design case. I am going to change something. I'm going to pretend like my reference building had an 8-inch thick concrete slab, 5,000 PSI. So now there's some difference between our two building types. When you look at the reports, so go up top to the menu, you can click on reports. It opens a new window. I'd like to look at the results using the graphs. You always want to click on detailed LCA results, operating versus embodied or assembly group. I think it's much more helpful to look at assembly group. We're not importing operating data. That's something you can do with Athena. I've never personally done that. But if you wanted to get that life cycle look with operating energy plus embodied energy, you could import that data. If you're not doing that, just click the assembly group. And here's our chance right below that, the system boundary. It says A through C or A through D. So I'm always going to keep that selected as A through C for a B3 project. And then it asks you what measures you actually want to take a look at. If you click all, you will get a plethora of graphs that just fill up your screen. I usually select one or two to look at. let's say global warming potential. And then finally down here at the bottom, you'll notice they do have so Athena does have a bill of materials. If I clicked on either of these two, I would get a report of all the materials that have gone into creating this half-baked house here. And that would be comprehensive of everything that's in the LCA model, including the extra materials that I've added. I'm not going to open that up right now, but if I click show reports, then it's going to open up actually 3 windows. So one is called calcination, and this happens when we're looking specifically at global warming potential. The calcination is something that Athena splits out separately just for concrete. It's the amount of carbon or CO2 that's given off as the cement is being baked in the kiln. That's my understanding. So the limestone is turning to lime basically, and it's emitting carbon dioxide in that process. I don't know why Athena separates that out, but it does. They must have decided that was important for their concrete manufacturer benefactors. But it has been split out here. I generally don't look at it, but just know that the global warming potential associated with that process, with the calcination, is included in your other charts anyway. So this is just pulled out separately if you want to identify it on its own. The other one to look at here is this biogenic carbon. So here you see all the numbers are negative, and it's showing negative numbers in my walls where I had wood studs. It's showing negative numbers for my roof where I had wood joists and roof sheathing. So again, this is that carbon storage that's associated with wood. And you'll see here that it's noting this is from phase A to C. And so that's a little mysterious to me. I don't know why the biogenic carbon is in these phases.
Case that the carbon sequestered as tree growth, so it would have been clear production.
Yes, but the whole idea of phase D is to incorporate effects outside of that. So it would be where, for example, steel recycling is taken into account. Phase D is where you go beyond the system boundaries. So if you were just looking at this house, everything outside the system boundary. But I don't understand why exactly it's
Phase D was like after demolition.
After demolition. Well, that could be for the recycling for steel, for example.
Trees, it's sequestered during the growth.
Okay.
We don't talk about what happens with it.
Yeah. Now for phase D, Athena does assign wood another negative impact in phase D. So I'm not sure why is it being given another carbon benefit after the buildings have been demolished. My original understanding was phase D was where that carbon was accounted for, but
it looks like in 2003, biogenic carbon was moved out of Module D and into the correct modules per ISO 21930.
Okay.
So I'm not familiar with that. But
so the interesting impact of this is that the more wood you have in the project, the better GWP it will have. So if you want to get your 10% savings, just add a bunch of wood. The more wood, the better. So
permanently installed.
Permanently installed. Tell your engineers to double up all their wood beams.
Get black every.
All right. So that's biogenic and calcination. This is really the chart to look at. You can see here how the biogenic carbon is included in this totals chart because the roofs are negative here. We only had wood in that assembly, so it's going negative. This is generally the chart that I rely on the most, and you'll see down here below they have, graph. they have a separate chart. And you can actually export this. I'm forgetting at the moment where that was. You can I might find this in a little bit, but you can export these directly to Excel. So if you don't like the way the graph looks, or you want to copy and paste all those numbers into a separate Excel sheet, you can just export it directly to Excel. So that's kind of a nice capability that Athena hasn't always had, but it does have now. Here. Thank you. So I can export it to Word, Excel, or PDF. Yeah. Let's see.
And this would be like, say, your base model, and then you would do it again, or
Yeah, so you'll see there's the two P's there. I've got the tests and the copy of tests.
I see.
So I've already got two, and this is what the last thing I wanted to show here. So when I have two projects like that, when I click on the reports, up at the top, it gives me a tab for project comparison graphs. If I click that, I can select all the different projects I have in the tree on the left. And then when I do my graph, now it's side by side. So I can see, okay, yep, in the copy of the project, I I increased the thickness of the concrete slab. So I'm seeing that show up there. So there ends my walkthrough. I think you can see it's pretty simple. It's pretty straightforward. There's not a lot to this program, to be honest. It's great for early phase work. I wanted to so this is the PowerPoint, the PDF that I will send you in a few minutes. But I wanted to open that up. You will get this in your email. This is the in-class exercise. So we'll be working on this model that you've seen before. We'll be trying to create this now in Athena. And there's quite a bit more to it than the house that I just built. So we'll probably be working on this for maybe half an hour and 45 minutes, and we'll check in. I'll be wandering around. If you have questions about how to add certain things, or you don't where to find it in the tree structure, just raise your hand and I'll stop by and try and help you out. These are the general settings. So this is what we're going to try and build. So the next few pages of this PDF are going to list for you what you're specifying in the model. So it covers columns and beams for the roof, for the floor. It covers the different types of foundations, so the strip footing, pad footings, the slab on grade. It gives you all the details you should need to enter it successfully into the Athena windows. The floor is going to be an open web steel joist. It tells you what the span and width should be, what the roof assembly is, what the wall assembly is for the foundation, as well as the exterior wall above grade. So that one is just like we created in the house. In the foundation wall, it was a CMU wall with an interior stud wall. This is the same idea. We have an exterior concrete block wall and then a secondary steel stud backup wall for the interior finishes. I think I made note of this window already. And then this is just a screen showing how to get to the right reports. We talked about calcination and biogenic GWP already. Yes, so once you're done with creating the base model, let us know. And when most of the class is ready, we'll get back together and we'll try and compare results and we'll see how consistent we can get. Okay? That'll be an interesting demonstration.
Actually.
Okay, the PDF should be sent. You can check your emails. If you don't get it, let me know. But here's now we're going to start our in-person work. Again, if you have any questions, you're having trouble getting it started, or just where to find a certain material or how to input it into Athena, raise your hand and I can stop by and help you out.